think we're up and running. Yep. I feel like I'm forgetting something. I'm probably not. But I sure feel like I am. Oh yeah, the music level. That's the only thing. I hope that'll be good enough. I feel like that's still quite part of the song. Come on. Get loud. Okay, I think we're good. Okay. So the plan for today, until I get distracted, is to try out some puzzles, which is unlike me, but I wanted to mix it up and get some not like college/graduate level math on the stream. So this seems like a good way to do it. I don't know what's happening in this picture. It's a very weird looking cat. Its face is a little too, it's almost human-like. That's what makes me uncomfortable about this cat. Oh, we even have bookmarks. Oh, that's amazing. I love me some bookmarks. So yeah, wait. Oh, that bothers me. Why is there only one of these things hyperlinked and everything else is not? Okay. I thought these first two titles were kind of funny. Amusing problems, difficult problems, just like yeah. Mathematics and almost no calculations. That's an interesting title. Numbers ancient but eternally young. That's mystical sounding. We're gonna start with the beginning though. Let's see how amused we can get. That's a nice drawing. Okay, to see how good your brain is, let's first put it to work on problems that require only perseverance, patience, sharpness of mind, and the ability to add, subtract, multiply, and divide. Okay, that's a lot of things. I don't know if my brain can be this many things at once. Observant children. A schoolboy and a schoolgirl just completed some meteorological measurements. They're resting on a null. Oh, is that what this is supposed to be? It doesn't look like school kids, but okay. Wait. No, I'm cursed again. I don't know who got first. As soon as that happened, there's an error displaying chat. Oh my god. Don't do this to me again. Okay, I can see chat again. Was that you got first, Skirt? Congrats if so. No, I like as soon as you, whoever it was you, okay. So as soon as you redeemed that, it said my chat window said there's an error displaying chat, and it had the exact same thing happen to me on Saturday. And I couldn't see anything. Yeah. Yeah, the effect on technology, you break them and stuff. Apparently, you just break everything, Skirt. Okay, so a freight train is passing its locomotive fiercely fuming and huffing as it pulls the train up a slight incline. You can try, Skirt. You can try. Along the railroad bed, the wind is wafting evenly. This is kind of poetic without gusts, just the way it's written. What wind speed did our measurements show? The boy asked. 20 miles per hour. That is enough to tell me the train's speed. Is it? Well, okay, I'm also dubious. Is that Danger TV? Sorry if I'm saying that wrong. Buckingham's theorem. Let's Google that, because I've never heard of it. It depends on the integral, KD7. If you want, you can post it and I can tell you. Dimensional analysis. So it is that dimensional analysis that I know of, okay. You're developing a game? What kind of game? Formalization of Rayleigh's method of dimensional analysis. Theorem states if there's a Gunnar dating sim for maximum profits. That's all I need to hear. I'll buy it 20 times. Lucy's theorem states if there's a physically meaningful equation involving a certain number of n physical values, then the original equation can be written in terms of p equals n minus k dimensionless parameters. Oh, okay. That's that's even better, Skirt. I'm glad that you don't charge for gooning. Or, at least you make the charging optional. Yeah, the Discord works in like math discussion. The rank of a particular matrix. Why is it? What's the relation to pi here? I wonder. I guess that's just the name of the parameters. Why we? Okay. Romance moves you in a new direction. Oh my God, Skirt. Yep. If the fortune cookie says it must come true. You're moving to America. Okay, let me take a look at what you posted so I can tell you if I think I can do it. Jump into a volcano. And apparently there's plenty of them around you. Mecha game when? I mean, I'd be down to play it again whenever. If you want me to actually like invite a bunch of people again, I could do that, but I do hate organizing stuff. Yes, see, that's my problem too, Skirt. That's also why Outlast Trials hasn't happened, because I'm too lazy to even invite 3 people for that, much less like 10 people for Mecha. Okay, KD7, I can do your problem, I think. Just let me keep, just sort of, since the other person asked first about Buckingham's Pi Law, let me keep talking about that for a minute, and then you'll be on deck after that. Just send telepathic waves to each other and hope we get a lobby. This feels like we're just gonna be in a lobby together and no one's gonna show up to our birthday party, Skirt. Okay, so Daintra, your question was how reliable is it? And I've had questions like that before, and I'm not quite sure what they mean, because theorems are always true when they apply, and well, at least they're not really true if they don't apply. It's not like there's not like a probability of it working or not working. So I never heard of this idea before. I guess it makes sense. I'm not sure, like, Like, you can always mess with the units of things to kind of make it however you want. So it makes sense to me that a theorem like this would exist. And once you get to a certain point in physics, to my understanding, you kind of shuffle the units around so you don't have to worry about them at all because they kind of start to get in the way. But yeah, I'm not sure what you mean by reliable. Like, is it helpful? Yeah, probably. I'm not good enough with physics to tell you exactly how or where, but go see your next birthday at Dave and Buster's. Do you even have Dave and Buster's there? It's a very like random thing for America to have like exported. Unless you're moving to America quick. You have a patent? Oh, hey, well, good luck with your patent. Yeah, Danger. I wish I could tell you more, but like, if you're meeting the conditions of the theorem, there's no reason you can't use its conclusion, if that's what you're asking. It can be like iffy about whether you do meet the conditions of the theorem, like maybe you haven't formulated your problem correctly, but yeah, I think that's all I can really think of to say right now. And hey, Jed. The pleasure of what we enjoy is lost by wanting more. The pleasure of what we enjoy. Oh, that's a good fortune. I bet. And Jed, once there's a break in the questions, I found this book that uses like not super complicated math, because I've been thinking about what you've been saying about like how it's been hard to keep up with the stream with like my homework being so complicated, and I agree with that. So once there's a break, I'm planning to see what these puzzles are like. They're supposed to not be too bad, or at least like not do use super advanced math. Okay, so we're gonna move on to KD7's integral. There's a company here that fucking imported a lot of American shit. So hence we're able to LARP as the Texas Roadhouse. Okay, yeah, that makes sense. Okay, I've only been to Texas Roadhouse once, but their rolls with the cinnamon butter is kind of are amazing. Okay, so we have an exponential curve up here. And we're interested in the area under this curve between 0 and 1. Sounds good, Skirt. Enjoyed the gym. Thanks for the lurk. And we're doing a Riemann sum. Okay. Yeah, I think I know what to do here. So this is going to be, if you're uncomfortable with using like ends, I would say just take this problem slow and start by like just letting n equals 2, then n equals 3, n equals 4, and you might see the pattern kind of emerge. I'm just going to go straight to trying to do this in terms of n though. So first, let's figure out the area of just one of these rectangles. So the width of each of these is just 1 over n. Because like this width between 0 and 1 over n is 1 over n. Same with this width here. Same with that width there. So the width is always 1 over n. The height that's going to be like, it's basically like this point right here, which we can evaluate using the function. And I'm sure, it's 1/2 times 3. And so this is where it gets a little bit weird. It's like the first rectangle we're valuing at 1 over n. The second one is 2 over n. So I'm going to make a new number like called small n over n. And so small n, like if our first rectangle is here, then small n is 1. Then small n is 2, 3, 4, all the way up to capital N. And so we want to add up all of these rectangles. So what we're going to do is do a sum from n equals 1 to big N of width times length. Syntax. Got the results, double A's on topology abstract algebra exams. You did it in less than an hour. Double A's. Congratulations, dude. Really well done. And yeah, we're doing some Riemann sums. Okay, so I think this setup is correct, and this is equal to u sub n. It's not me, it's you. And so the neat thing about this sum, take the common ratio out. Yes, perfect. This 1 over big N and 1/2, they have nothing to do with small n, so they can come outside of the summation. Oh, you know what? There's one more thing that we should take out. Okay, so before I actually do that, like this looks a heck of a lot like a geometric series. Yeah, and okay. I would write it a little bit differently. I would write this as n equals 1 to n, 3 to the n times 3 to the... Wait, no, that's not how that works. Never mind. Maybe we do have to write it how you wrote. Yeah, I guess... Yeah, you're right. We have to write it like this, and that's okay, because big N is just a constant, so this is fine. Okay. And so there's a formula for the sum of a geometric series that I need to look up to remember. Suna, hello. How's it going? Geometric series sum. I know the way to like prove it, to actually find it. I'm just kind of lazy. Actually, this link here gives the proof. It's not too bad. You just kind of use a trick. This is our formula here. We do have to remember this sum starts from 0, though, and our sum starts from 1. That's okay, though. We can make it work. Yeah, that's it. As syntax says. Yeah, let's bring this down here. Okay, so we want to force the sum to start from 0. So what we can do is just write the sum starting from 0. And then subtract off the thing that we added, which is this thing with n equals 0, small n. So that's 1. And just to be clear, this is the only thing being summed. The minus 1 is outside of the summations. Maybe I should also do extra parentheses there. And now this bad boy, we can apply this formula to. So r is going to be 3 to the 1 over n. So 1 minus 3 to the 1 over n to the capital N plus 1 divided by 1 minus 3 to the 1 over n minus 1, like that. And then hopefully once we clean this up and get a common denominator, we're going to get the answer in the question. So I guess common denominator is a good first step. I think that's proper. So we have 1 minus 1 cancels. We have minus 3 n plus 1 over n plus 3 to the 1 over n. We're gonna factor out a thing. I guess a 3 to the 1 over n? Well, that's not ideal. That's not the cancel. I wanted this to cancel with the denominator. We're not getting that. We almost have the intended answer, actually. Like, somehow this thing should have ended up being a 2, and we'd have the exact right answer. No, I mean a negative 2. So what went wrong? I don't think there's another expansion to use. Hmm. Is that I feel like that this formula, like, there should be a way to make this work. I think I'm just doing something wrong. Hey, Kubrick. That's not the question. They're asking us to get the actual Riemann sum. I do wonder what Wolfram Alpha, if Wolfram Alpha can actually simplify this for us, just to verify that like, is it in the setup or in the algebra? So I just want to give Wolfram Alpha maybe that line of math. I don't have to enter a summation in natural language. Summation, not a... Oh yeah, it is, okay. Do you know what to do with this? That is the right answer. So I just made an algebra mistake. So my mistake is somewhere in here. This is really annoying. Is there a different expression for the sum that I'm missing? Okay, let's try this version of the formula. I think it's maybe what you posted too, KD7, or similar enough. Um, okay, so A... Wait. What is this A? This is not written correctly. I'm going to a different website. I no longer trust that website. Well, it should be a times r to the n, but they didn't write the r to the n, so I was confused. Okay, so it's the n-1 thing that was confusing. Okay. I think that's probably correct, Katie7. Yeah, let's try that. So I was just working out in my head. And I think that formula checks out. Wait, this exponent here. I guess it's just. Is it just? Oh, it's just 3. Oh, I see. Because it's n over n, big N over big N, and that gives us exactly what we want. So yeah, there should be a way to salvage this work. I don't see it though. In this way is much easier. Okay. Cool. Do you want to talk about any of the other pieces, or was it just that you wanted to ask about? Sounds good. Thank you for the question, Katie7. Okay. So unless someone else has a question, we're gonna take a look at some puzzles. So I was reading through this one. Let's read it from the top, because I already forgot about it. Observant children. A schoolboy and a schoolgirl have just completed some meteorological measurements. They are resting on a knoll. A freight train is passing, its locomotive fiercely fuming and huffing as it pulls the train up a slight incline. Along the railroad bed, the wind is wafting evenly without gusts. What wind speed did our measurements show, the boy asked. 20 miles per hour. That is enough to tell me the train's speed. Well, no, the girl was dubious. All you have to do is watch the movement of the train a bit more closely. The girl thought a while and also figured it out. What they saw was precisely what the artist has drawn. What was the train's speed? Really? Where are they measuring the wind? That seems like an important detail. I don't see where. Okay, so I assume this means that the wind speed is constant along the railroad bed. You have a thought? What's your thought? Hmm. The wind is blowing 20 miles per hour in the opposite direction of the train's movement, so the huffing and puffing just creates a cloud that follows the locomotive. Hence, the train is going 20 miles per hour. Oh! That's clever, Jed. Yeah. So the thing that you notice is that this puff of smoke is like straight vertical in the air. Oh, and they have the detail that all the other like the clouds and the other like smokestacks are all going with the wind, but the trains is not. So yeah, the train is going 20 miles an hour also. That's smart. I was focusing too much about the incline piece. Someone swinging in one of those infinite current pools and going nowhere faster than swimming, same speed as water's moving. True, yeah. Okay. You know what? I buy this chapter title. That was an amusing problem. No, I think you're exactly right, Jed. Like, I didn't realize that detail. Oh, they even have the ship going faster than the wind in the opposite direction. Yeah, this is a clever picture. Or no, sorry, the smoke like this smoke's going in the same direction, but it's a lot like flatter. Huh. Okay. Let's move on to the next one. There are answers, but let's I feel like we got it there. Oh, oh, okay, okay. I believe you. No the smoke coming out of the locomotive chimney. If the locomotive was standing, its smoke would be going in the wind's direction. If it was moving forward in the absence of a wind, its smoke would be inclined backwards. That's shown opposite page 1. Smoke with the moving locomotive is straight up. Therefore, transmitting the speed equal to the wind speed. Okay, yeah, you got it. Okay, Stoneflower. Do you remember the smart craftsman Danila from P. Bezov's fairy tale The Stoneflower? They tell in the Urals that Danila, while still an apprentice, took semi-precious Ural stones and chiseled 2 flowers whose leaves, stems, and petals could be separated. From the parts of these flowers, it's possible to make a circular disc. Take a piece of paper or cardboard, copy Danila's flowers from the diagram, then cut up the petals, stems, and leaves so you can put them together to make a circle. Well, I don't know if I'm going to actually do that arts and crafts piece, but we do have both of the flowers to work with. And this, you just move the little, we can maybe draw it in the journal. Oops, hit the wrong key. The only thing I'm not sure is how to use the straight lines. If we even have to use them. But like, these leaves definitely go in these like nooks up here. And then you can basically just make a pizza out of these pizza slices. The thing I don't know is like, well, it's what I already said. How do you use the straight lines, or are they just a red herring? Are they supposed to actually measure the angle of these pizza slices? 'Cause I'm not above doing that. If we have 4 slices, 360 divided by 8. We have eight slices, I mean. That's 4. Is that 45? It is. Okay, 45. So this angle should be 45 degrees. I bet I could actually measure that in a paint program. This is kind of overkill. I don't know if this is in the spirit of the question. I have both. My instinct was to go for paint.net in this situation for some reason, but GIMP we could also do it in. I need to remember how though. Maybe I should go to GIMP because I've used that more recently than I've used paint.net. Oh, true. Oh, that's so smart, Jed. Yeah, we can actually make it here, and if I can make it here, I can make it anywhere. Um, so actually, let's back up. Put this on a different layer. I don't know if actually. Okay. So on this layer, layer 2, can we get just that bit? Okay, let's do subtraction. No, oh, don't subtract from the current. Hold Alt while drawing with the left mouse button? Oh, tech. Okay. That actually still isn't quite right. Damn it. I need to mess with the tolerance, I guess. What? Excuse me? Bruh. Bruh. Oh my god. Okay. Paint.net, you're out. I'm firing you. Oh no, now it's gonna install updates. Ugh. I shouldn't have done that. It's a really crappy arts and crafts tutorial though, syntax. When I use the wand tool to just circle the shape, well, it was selecting too many things was the issue. Why isn't GIMP showing up in my OBS? It's not R, Phobos. I hit a wall with my R stuff. Um, the lasso tool. Yeah, that's what that would have been the smart thing, Jed. You know me though. I don't enjoy doing the smart thing. Uh, It just beeped at me. Finish. Okay. Oh, duh. We can still use that layer. Okay, lasso tool. Now, I am really OCD when I use the lasso tool. And I'm going to be probably more OCD than necessary. Okay. Copy. Wait, no, I'm on the wrong layer. Copy from that layer. We'll paste it onto this layer. Okay, that works. I guess we don't need this layer. Layer be gone. Selection does not intersect. Oh. Wait. Copy, paste. Don't do it to the original. Wait. Rotate, damn you. Okay. Well, I think I have it worked out, Jed. Really, the only thing I wanted to do was measure the actual angle. What are you doing to me, Gimp? Wait. Ah. What are you doing with my layers? Anchor this. Does it control H? I forget. It is. Okay. Conundrum. I guess so, syntax? What? Wait, how do I measure an angle? Okay, wait. Maybe I start from here. Then I click on that. No? God damn it. Stop it! I'm being bullied by a program. Like, what angle do you think you're measuring there? Oh, the angle of the line itself. Okay, I'm calling that 45 degrees. We went from 1 degree to 43 point whatever. And this drawing isn't perfect. I am down to get in Discord, Jed, but I think the answer is just you make the leaves go in the petals, and then you have 8 pizza slices, and the angles do add up to 360, so you're good. And you just ignore the straight lines. Every living person has shaken hands with a certain number of other persons. Prove that a count of the number of people who have shaken hands an odd number of times must yield an even number. Isn't it just a handshake requires 2 people? I think everyone is... The count of people who have shaken hands is always even no matter what, even without that restriction. You can't shake hands with yourself, so... I don't know what I'm missing. Because no matter what odd number you have, you're always multiplying it by 2. Wait, so yeah, okay. Let's just do like, if you have 3 people. I don't know, I'm actually drawing them. That's me. I've shaken hands. Well, I guess we need an odd number of people. Ugh. Okay, so there's 3 people. Let's say I've shaken hands with all 3 of these people. So I've done it with 3 people. These people are all 1s. So that does add up to 6, right? Well, I mean, the number of people. So not the number of times you've shaken hands, but the number of people. So that's still 4. Proof of shaking hands with another person is itself even. Every new handshake adds 2 to the total number of handshakes. Yeah, that's a better way of saying what I was thinking, Obi. Like, imagine a universe where no one has shaken hands ever, and then people suddenly start shaking hands. Every time someone becomes a handshaker. Well, oh wait. So we're just counting the people who have ever shaken hands. Hey, Cursological. So what about this scenario? So I guess it's not as obvious as I thought, because... Well, okay. In this universe, there's 3 total handshakers. That's the issue. But this is... I'm not violating, like, the statement of the problem, because this is an even number of handshakes. You rediscover the Riemann Sum. Ooh, cool. That's neat. Hey, Viv. I'm doing good. How about you? At least one handshake. Bit busy at work, but all good. It's good to hear. Hope your family's doing good too. Do the Riemann hypothesis next. Oh, the World Cup. Yeah, yeah. Yeah, I bet a proof by contradiction is the cleanest way of doing it. Um, let's assume it's an odd number. And then find something that goes wrong, I guess. So it's already eating on its own now, so that's nice. Ooh. That does sound nice. Own spoon and fork? Hell yeah. Do this via induction to n the amount of people, then adding one person, showing whether they choose to shake hands with any amount of people. Doesn't change anything. Yeah, I'm still trying to work out what the contradiction would be. Okay, I think the first statement we can make is can consider only the group of 2k plus 1 people. Does this make sense? Oh, maybe it doesn't make sense. I was going to say that if someone has shaken hands outside the group, then that person would have one handshake. Actually, I don't think we can say that. You've been working on a lot, just becoming dad doesn't mean you need to have a dad bod. Hell yeah, babe. Person contributes 1 to a handshake. He started with that. Yep. It's like there's kind of like a set theory thing going on here where in your total population of people, you have odd and even. But theoretically, someone in the odd category could have shaken hands with someone in the even category. As long as that person in the even category then shook the hand of someone else too. So like we um so like what I'm trying to say, Jed, is that like I think we need to go further than just that, because like so I think about like this 2k plus 1. The even part, the 2k, it could come just from what you're saying, where all these odd people shake each other's hands an even number of times. But then that odd person out, we have to rule out the possibility that that like last person shook hands with an even number person, and that even number person then shook hands with someone else in the even like subset. I think the task is to prove that that would cause someone in this even category to be odd at some point. Mm. It's got to be something like that, Jed. I'm just having a hard time like actually working it out. And did I already say hi to you, Rex? If not, hi. You'll travel to many places. Ooh. Um. Maybe should we just do a small example? Like, let's say, if we have a population of like 5 people, numbered 1 through 5. Let's say we have 3 people with odd numbers. Maybe this is too big of a population. It's gonna get a little weird. Let's say like that. So person 1 shook one person's hand. Person 2, well, that can't happen. Damn it. Do 1, 1, 2. Never mind. I want to do it the other way, so there's a contradiction. 1, 2. Well, I'm running out of people in my population. Okay, you know what? Never mind. Well, if the same pair shakes hands, I don't think that counts. That's how I'm interpreting the question. If that's what you're saying. Like, we're talking about... Oh, wait, does it count? Oh, no, I think you're right. It doesn't say that it doesn't count. Well, no, a certain number of people. This question seems to imply that it's uniqueness. Or it's like the unique pairs. But you're right, this sentence does not say that. Which one is right? I feel like because of the first sentence, we are going by body count. It's a number of people you've shaken hands with. And actually, that does mean we could say, if duplicates don't count, we could say that we have like n total people. Can we go for contradiction after that? It doesn't make sense to add variables. Does it make sense to add variables? I don't know what you mean by that. P equals the number of people, E equals the number of people who have shaken hands the even number of times. Oh, yeah. That's what I was thinking of. Like, something like that. Um, yeah, so I was thinking that, like, if P is even, then either E and P minus E are even, or odd. Like, both. Does that help us? Hmm. Focus on the hands, not the number of people or the number of handshakes. Maybe? I'm not sure where to go with that, Jed. Hey, Slim. But yeah, Slim. Like the only reason I stream is so I can wait and hope that you join. How's it going, Slim? Model it as a graph. Count the number of edges. Oh. I was not thinking about graphs. Let's start with maybe the even case for total population. So let's say one has 3 handshakes. What about this network here? Not Chris. The bucket hat turned out kind of pink, but the low-cut shirt is fire. Okay, let's see what this is. God. Surely this is AI generated, right? That's really funny. I love it. The throw pillow, oh my god. You got a whole merch line going. Very nice, Chris. Not Chris. It's known as the handshake lemma. Oh, cool. Um, so right now we have that has an odd number, that has an odd number, so that's even. What if I added an edge here? Yeah, apparently I'm in business for a made-up company, so if I add an edge here, you're even, you're odd, you're odd. You don't know graph theory, so that sucks. I feel like it shouldn't be difficult graph theory, though. Like, this feels like achievable graph theory that you could just figure out with some elbow grease. Oh, you know what? I don't know if you're still. Oh yeah, you are still here. Okay, but before I was looking through this book, which feels like a book that you have probably seen before. Before the syntax error gave us the question on screen. But when I saw it, I was like, oh, this book, it kind of reminds me of Slim. Oh, you haven't seen it? Yeah, I was just kind of looking around for like puzzle books for something to use as some filler on stream. I've only looked at 2 problems so far, though. Did I know about what? Harvest Moon? The game? Yeah? Use our Olympiad problem book? Oh. Yeah, I'm okay with not doing Olympiad problems. Oh, this one, I think we can do it. This is the first problem. Yeah, not Chris. I fucked up there, I guess. Yeah. Um. Now, it's probably not what we're supposed to do, but every time there's graph theory involved, I always want to mash linear algebra into it and make an adjacency matrix. Zach, thank you so much for the raid. Wow, you went for a long one. At least I think. I don't know. I hope your stream was good. I caught a piece of it. Hey, Winklebot. Ivan, but with location. Welcome in, people. We're thinking about this kind of like puzzle type question that Syntax Error gave us about the number of times people have shaken hands. We got a suggestion from Slim, aka kind of these ideas to think about in terms of graph theory, which I'm trying to like work out. And then once we're through with this problem, unless someone wants to distract me with another question, the theme for today was actually kind of puzzles. So I found this book online, and there's some cool looking puzzles in it. I've only looked at 2 of them so far, but so yeah, once we've either gotten completely stuck on Syntax's question or have solved it, we'll go back to doing those. Leo, funny to see you here. It's weird I never see you at the Leo lecture streams. I mean, I one day I will catch one of your streams, Leo, and it will be glorious. I seem to remember to check my YouTube more often. Think of degrees. Oh, the degrees of each node. Okay, yeah. True, that's the exact thing that we need. You have a proof of this problem? This chat section is too small to contain it. Classic Winklebot. Who knew physics could be so hard? It's not easy stuff, Zach, but it's so like beautiful. Like Gauss's law is so awesome, and getting all the way through to Maxwell's equations it's just even more awesome. The degrees on the East Coast? Oh, that too, yeah. Good luck to everyone on the East Coast. It sounds not fun. The implication of shaking hands means 2 people for 1 shake, right? That's what I thought too, Winklebot, but it's a little more subtle than that. It's we're counting like unique handshakes. So like I've shaken hands with 3 total people. It doesn't matter if I repeated handshakes. That's how I'm interpreting it. And so I was kind of drawing like thinking about it in terms of like set theory, and I'm working on a proof by contradiction. Or at least I was, but then this graph theory thing seems to be the way. Hey, Aeneas. The edges are the handshakes. The number of neighbors of a vertex is its degree. Right. The number of edges is equal to the sum of degrees divided by 2. Right. That's the key. You get multiple edges between 2 vertices in logic still... Really? Okay. Degree works for graphs and multigraphs. Doesn't matter which way you interpret it. Define never being at Leo lecture stream couldn't be me. That would be cringe. Stream on Twitch. You looked into the wiki. Apparently, Harvest Moon the game isn't actually a game. Just walk around and do air and yeah. You make a good point there, not Chris. I am streaming on Twitch. Define we are counting unique handshakes. Apparently what I'm saying isn't even true, Winklebot, so don't worry about it. I guess we're asking if I've shaken hands with 11 people in my life, which sounds low, and you count everyone else who's also shaken hands with an odd number of people, that number of people is even. There you go, Leo. That's the solution there. You've never shaken hands with someone. I mean, that's hygienic. So you need to count hands, not shakes. I assume we need to do both, Jed, and like shakes should be twice times hands or something like that. Permutation just a factorial. Yeah, Winklebot, that's how you count permutations. With ordering. No, without ordering? One of those two. With or without ordering. I don't remember which one. Yeah, I'll make a note for Leo. He this is Leo here. No edges. That sounds odd. That does sound odd, Max. It took me a second to realize what your joke was. This implies a statement. Okay. The sum of degrees is 2 times the number of edges. Well, wait. How are we considering the odd number of times piece, though? This is the sum of all the odd degrees, right? Not the sum of all degrees. Like, this formula is for the sum of all degrees, but we want the sum of odd degrees. What happens if you break it into even degrees and odd degrees? What happens? What? I don't know what happens. Sum of... Oh, wait, odd plus... Or, no. The sum of even degrees is always even. The sum of odd degrees could be either. Okay. This notation could be a lot better. But I think the point is that this sum here is always even. We know these both must sum to an even number. And this could be even or odd depending on how many odd numbers we have. But we know the entire thing has to be even. Okay. That's such a neat proof. Even or odd. But odd would cause a contradiction with the right side of the equality. That's the proof. Okay. That makes a lot more sense. My notation sucks, but I don't know how to write it better. I'm behind on chat. Let me catch up. The sum over even handshakers is even. If odd shakers amounted to an odd number, sum would have been odd. Yeah. I may have said my genius rediscovered your own sum. Oh yeah, I can take a look at that, Cursological. The set of people who shook hands an odd number of times is odd. That makes an odd number of hands. Handshakes require an even number of hands. Something like that. I don't know. What I've written here makes sense to me now. We also don't know if the grip of the shake constitutes a real shake. We also need to know the potential grip strength. True. Okay, right, slim. Maybe we could do some kind of induction. Always eliminate one person with the current property. That's what I was thinking at first, Max. That this graph theory thing is really nice. Suppose there are 2n plus 1 odd shakers. Some 2n over odd shakers is even. Lots of shaker make it odd. Means we have a factor of 2 still in the odd case. Thing multiplication. I'm weak too, Winklebot. I reduct your Obsidio and substitute my own. Why not build it from the ground up? Start a set of n people who have all never shaken hands with each other. Let them start shaking hands with each other, one handshake at a time, and go by cases. The parity of the odd group can never change. Okay, Hideous. I'll forget about it. I mean, this graph theory thing is so, like, short. But you could do that too, I bet, Fembox. So this proof is also integral. I was about to say integral. It's also integral in algorithmic game theory such complexity theory is a class called polynomial parity argument. Ooh. During that class, you were given a large graph with an odd degree node. And your problem is to find a different odd degree node which is guaranteed to exist. Oh. That's cool. I wouldn't let my people shake hands with each other, Fembox fan. I don't want to feel left out. Yeah. Wait, odd plus even. Oh, because they swap places. I see what you mean, Fembox. Okay, yeah, that's clean too. I also like that. Yeah, that's a nice like an induction way. You started reading that graph theory book. You've been sidebarred into learning set theory now because it turns out it's a prereq. It kind of is, Winklebot. Set theory is important, as it turns out. I wish it wasn't. There's a lot of set theory you don't need to know, though. Like, I don't know very much set theory. 83? Oh, that's good. Could be a lot worse. To anyone out there feeling lonely, I'd advise starting a business. Even if it's small, at least you'll have a little company, G-Hive. You make a great point, G-Hive. Bye. I hope your day is going well. The zero is even a certain number of persons could be zero. By default, isn't the result even in that scenario? But then the number of people who have shaken hands and a number of times is also zero, and zero is even. Oh yeah, so yeah, there's no contradiction there. Not Chris, I don't think. The existence of second odd degree node is exactly this argument. That makes sense, Leo. A lot of these cute existence proofs and combinatorics underpin a complexity theory class. No, you need to know about strange set theoretical universes to do any math. I'm glad you don't. Set theory gets weird. Okay, so let's look at Cursological's Riemann Sum rediscovery. Except DM. That's a nice problem, syntax error. Thank you for sharing it. Mathematicians be crazy. They rewrote their entire firmware and infrastructure in the late 1800s, early 1900s, because apparently contradictions are bad, whatever that means. Yeah, and then there's even like a choose your own adventure if you want to take the axiom of choice or not. Made a little mistake that even plus even actually increases. Oh. Yeah, that's true. That still works though. Let's look at Leo Extreme said anybody but Don. One day it'll change, Leo, and we'll have a party. Furniture writing firmware today because that firmware is so dog shit with computers. The function y equals f of x, c0 equals a, be the start interval, cn plus 1 equals... Oh, I think there's a mistake with the interval, or like with the subscript. Yeah. I feel like the curse logical. Hey SK and hey Escained. Let c sub n for n greater than 0 be a dividing point of said interval. Yep, makes sense. For finding area, let's consider one point for n equals 1. Make the area under the curve approximated as... Ooh, what are you doing here? Oh, you're saying for n equals 1. Okay. Yeah, sure. I guess that works. Easy 100 degrees? 100 degrees is terrible. Or wait, are you making a joke about boiling point? I don't know. Slight breeze, sparse clouds in 78 here. Nice. It's cloudy here. There's actually a chance of rain, but it is... It's 7 degrees out right now. And I'm very happy that it's below 70. The sun's getting into? Maybe I haven't gone that far yet. Oh, it looks like they did, yeah. Generalizing this gets us the following. Right? This can be denoted with the sum. Yeah. This looks reasonable. This is for like a right-handed Riemann sum. Well, okay, I think it should only be up to n, not n plus 1, I want to say. Because you don't have c sub n plus 1 defined. Well, oh no, that's b. Never mind. Okay. Oh, yeah, oh, okay. Never mind, this is fine. So yeah, this is a right-handed Riemann sum. Some people call this the partition, the maximum interval. So this sum did get eaten, it looks like. 7 degrees is cool in multiple ways. I'm not sure what you're doing on that second line. I assume maybe you're taking a uniform interval is my guess. Yeah, you don't need the rectangle sizes to be equal. It's just easier if you do, but it's not actually required. You could have just left it as like the maximum going to 0 and you'd be equally as well defined. It's a lot easier to do math when they're all equal though. Yeah, I'm not sure why, but it's more common for me to see the rectangle sizes not being equal. And I don't quite know why you wouldn't make that simplification. I don't think it makes a difference, and it's just easier to work with, but a lot of textbooks I see do leave it in the more general form, and I'm not quite sure why. But yeah, no, I mean, it looks to me like you did a good job of rediscovering Riemann sums. Like, this is the... From what I can see, at least, this is the exact, like, right idea here. Your face would be equally well defined, you're crashing out. Ludwig with the classic train problem. Okay, so Max, you're talking about like the Dirichlet function. Does the interval width like you're is that why they do it? either way, I feel like it should get you 0 for the Riemann integral. I don't actually know like how you prove that though. At some point in my life, I need to go through and do the constructing real numbers from the ground up thing, because I haven't actually done that. I feel like that's kind of a big oversight. Well, I thought you could Riemann integrate it, you just get 0. Or maybe 1. Depending if you do... I guess you would get 1. If you're integrating it between 0 and 1. You can't? The rationals are dense. The rationals are not dense, I thought. Like, no, wait. You mean the irrationals are dense? I thought the fact that irrational numbers exist is the very reason why... Really? I thought that... Okay. I don't know what dense means. They weren't equal size. Couldn't you make one giant rectangle, the rest be in the smaller interval? That wouldn't be exact. I mean, it would be a crappy approximation, cursological. But the point is, you're taking the limit as the biggest one goes to 0. So that giant rectangle will always get split up eventually. Yeah, you're right. It'd be a terrible approximation, but you're making it exact once you take the limit to 0. Only valuing some at rational numbers, we require conversion for an arbitrary choice of point in interval. It's different. Okay, yeah, that's where I was stuck, Aeneas. Your C sub I always stay rational, it's converged to 0. If they stay rational, it converges to 1. Okay, so you can find 2 different results with this process, and that's why it's not integrable, because you have a contradiction. So we're also taking uniform intervals. Yeah, I guess if you do always take uniform intervals, that sum should converge to 1. Because I think if they're uniform, you're forced to always stay rational. Irrationals are dense too, but more dense. Okay. Find many different results. Chat, proving make it equal a number between 0 and 1. Oh, I think I see how. Yeah, by using non-uniform intervals. Hey, TVSR. So I guess that's why I guess they make the definitions like that because they want the error to occur with the Dirichlet function. Like, you don't want that to be Riemann integrable, I guess. Oh, yeah. That's fair enough, Max. I was mentally saying A equals 0, B equals 1. But if you start with irrational A and B, then yeah, fair. You just want a general? I don't know. I don't want a general. Maybe you want a general, Leo. I don't want a general. These were a break if it wasn't general. Okay, fine. Maybe I do want a general. Okay, Ludwig asking about trains. We can make linear functions with these, right? I always get tripped up on like how to deal with the head start though. That's the issue with these questions. Okay, so I think what we can do is take this as our 0 time point and just assume and just let this train have a head start. So If they ask chugga chugga, the answer is always choo choo. True. Okay, so train 2 is the easier one to start with here. So I would say train 2, we're just going to say if the position of train 2 is 90.5 times time in hours. Train 1, dark, there is an actual dark mode somewhere in the preferences, but that only changes the toolbar. If you want to change the actual background, shoot, you can't see the dialog windows that are coming up, but at the top in journal and this drop down thing, there's a paper color that you can change. And then I just redid my toolbar so that the white marker shows up first. So you have to do a few steps. There's no like one setting that you can tick for everything, unfortunately. Say the spire time, soccer slop watching time. Sounds good. Hopefully I can catch it, Leo. Enjoy your gaming and soccering. Train 1, it's travels at 62t or at 62 miles an hour times time, but we need to do a plus whatever head start it got during this time. So it's not quite 24 hours. This is so annoying. So it's 24 minutes. 24, wait, okay, so let me, we have to do date math, which is the worst type of math. So, the minutes, 24. The hours, 12 hours gets us to 3 a.m. Another 8 hours, so 20? 20 hours and 24 minutes. Okay. Are we covering accessibility settings? Oh, I didn't know that. The only other thing I changed was, how do you customize the toolbar again? It's been too long since I've done this. Oh, okay, wait. Sorry, I forgot to tell you something. In the journal drop down up here, there's a configure page template thing. That's what you actually want. So your default page becomes this like dark page. Plain, yeah. You want plain. At least you probably do. Customize. Oh my god. Okay, yeah, I forgot. This is where it gets crazy. This is where I did it though, I think. And you can't see the dialogue that's popping up. But I went to view, toolbars, and then customize. And I just put the I think you just drag and drop it so that the white marker comes first. And like my black marker is just in this drop down and I never use it. Okay, so the position of train 1 at any time is 62 times time plus whatever head start it got. So the head start it got was the speed it traveled times the time it traveled, which is 20 hours plus 24 over 60 for the minutes. Edit toolbars? No, for me it's in view. Maybe I probably haven't updated my Journal++ in a while. That could be an issue. But for me it's in view. So yeah, Ludwig, I'm not sure if you're still here. Let me know if you are. But at this point, we have the two equations that we need here. I would set them equal to each other and then solve for t. I didn't see you type anything, so I have a suspicion that you may be left, so I'm going to leave the problem here. But this is how you would set it up. Oh, you are here. Okay. Okay, I'll keep on going then. So we'll just do what I said. We're gonna hopefully you understand how I got these two equations, but that's kind of the hard part. We want to find out where they meet each other, where they travel the same distance. So we're just gonna set these two equations. I don't know what I was drawing there. Equal to each other and solve for t. 62 times 20 plus 62 times 24 over 60, just distributing the 62 in. And then this is kind of becoming work for a calculator. What version do I have? I have 1.2.3. I haven't updated mine in forever, I guess. I assumed it would update on its own. Apparently not. I'm going to make Wolfram Alpha solve this for me from here because I don't want to do this mentally. Or at least by hand, anyway. How do I install it? Probably just whatever was on their website. I'd have to look again because I don't remember exactly. I see, so Wolfram actually shows us like the graph of these two lines, and that red dot is where they intersect. And so this is the answer as a fraction. You probably want it. They want a date and a time though. So we'll call it 44.38. Why not? So the last thing to do is convert it back to a date and time. So remember, this is 44.38 hours after April 13th at 11:45 a.m. So 0.38 of an hour. We want to figure out what that is in minutes. So I'm going to multiply it by 1 minute. Sorry, 60 minutes divided by 1 hour. Just a unit conversion. The hours cancel out, giving us just minutes. So 0.38 times 60. Going back to my calculator. 22.8 minutes. And I'm going to call that 23 minutes just so we have nice round numbers. So we want to take April 13th at 11:45 a.m. and add 44 hours and 23 minutes, and then we have our answer. So to add in 44 hours, 12 seconds off? I am? Or what do you mean? Like 12 seconds off of a round number? Oh, you mean, oh yeah, this estimate? It's fine. um, so the first thing I'm going to do is I'm going to add 24 hours to this time, because adding 24 hours just turns the date forward by 1. April 14th at 11:45 a.m. And we still need to add in 20 more hours. So instead of adding 20, I'm going to add 24 and subtract 4, because that's a little bit easier for me to do in my head. So turn the clock forward by another day, but then take 4 off of our hours. So 7:45 a.m. Because 11 minus 4 is 7. Okay, so now we need to add in the 23 minutes, and we're done. Seven. Oh, you're kidding me. Okay, we need to go up an hour. 8:13? Am I mathing correctly? It's 8:03, isn't it? It's 8:03. Okay. I think it says April 15th at 8. It is 13? I think it's 03. No, you're probably right, Femvox. No? Wait. I'm so confused. Why is this the hard part? $8.08? Wait, why am I saying 03? Yeah, 8:08. Thank you. That sounds much better. Oh my god. Okay. Sentence when something works, there are no new features 1 month. Such bugs 1 month's fixed. Updating is the best, or not updating is the best. Yeah, that's true, Max. At some point, I do want to make a plugin that integrates Journal++ with Twitch. I've been saying that for years though, and I still haven't done it. But I guess once I get around to doing that, I'm gonna probably update it. 808 plus or minus 5. Clock math is hard, or date math. Insight GPX. I see your question there. I'm just I haven't read it yet. So Ludwig, there's the answer there. I hope that helps. Let me know if you have any questions. Okay, slight GPX. Why mapping to scalar is so useful to explore deeper structure of space? For example, V star equals homology VIR or cohomology? Ooh. Yeah, I'm sorry. I don't know anything about homologies. Homomorphisms? I only vaguely know what a homomorphism is. V stars probably? If I just Google it, will something relevant come up that we can talk about? I definitely don't know the answer to this from, like, my own knowledge. No worries, Ludwig. Twitch chat voice synthesis? Oh, that sounds very chaotic. That's cool that you made this. This would... I don't need more voices in my head, though. That sounds really funny, though. A per user voice, too? Oh, I love that. Especially people can, like, customize their own voice. Oh, it has to do with tensors. That must be why it has something to do with the structure of space. This is way, way beyond me, but I would guess if they have something to do with tensors, then that's probably it. I'm not seeing something that's really responsive to what you're asking about, though. Slight GPX. So yeah, I'm sorry. This is beyond me. Uh, it seemed like there's probably something there, though. Okay, wait, look. Unless someone else wants to ask another question, I'll go back to doing these puzzles, but let me see what's happening in chat, because I'm behind. Doing the implicit differentiation portion of Stewart right now, in the study for the GRE, they make a passing reference to Galois theory. Huh. I don't know anything about Galois theory, so... Actually, I actually did just read that there's a thing called differential Galois theory that can be used to prove existence for, like, solutions to differential equations, I think? And so if that's true, then maybe... implicit differentiation is kind of sort of related to differential equations, I feel like, so. Abel and Galois, the Norwegian mathematician Niels Abel, proved in 1824 that no general formula can be given for the roots of fifth degree equation in terms of radicals, right? Later, the French mathematician Évariste Galois proved that it is impossible to find a general formula for the roots of an nth degree equation to algebraic operations on the coefficients if n is any integer larger than 4. Is that relevant to implicit differentiation? Dumb input. That sounds familiar. Okay, so again, if someone has a question, feel free to tell me. Otherwise, I'm going to go back to doing amusing problems. We've already talked about number 1 and number 2. And so number 3 is next. Tycoon terrain? Oh, we did. Yeah, I remember that we talked about that. That's relevant because you can't solve in terms of radicals and then differentiate. If you know with a degree 5 or higher polynomial relation. Oh, okay. Yeah, if you have like a y to the 5th plus 1 or something. Okay, okay. I don't know, y to the 5th. Yeah, implicit differentiation is a lot easier though. Okay, that's fair. Okay. Actually, I'm going to get distracted by the later on puzzles, so let me scroll up a little bit. Moving checkers. Place 6 checkers on a table in a row, alternating them black, white, and so on as shown. Leave a vacant place large enough for 4 checkers on the left. Move the checkers so that all the white ones will end on the left, followed by all the black ones. What? Checkers must be moved in pairs, taking 2... Are they saying to reverse the alternation? I need to read this a few times to understand what they're saying. Because the interaction of dual objects reveals constraints on how the original objects may behave. In category theory, every theorem proves a co-theorem in the co-category. What? I'll have to take your word for it, Flofi. If you use math to make a cool shader, you've never used it before. Shadertoy.com/new. Oh, I've heard of this. I saw a YouTube video about it. Like, making art with math and programming was kind of the theme. I forget what video that was, like, or like who made it. This code doesn't make any sense to me as I read it, but noise functions. Perlin noise. I remember reading about this. Oh, that's cool. This isn't the thing like what you're thinking of, though. I don't think. Sine distance functions? Maybe, Max. It's been too long. That doesn't sound familiar, but it could have been. This is the base shader? Okay. Ooh. I can see Perlin in there. Yeah, that makes a nice pattern. Um, the FPS, yeah. I don't know what this is actually doing, though. A lot of dot products. They're hashing something. I don't know why you would ever write a math statement like this, but okay. Oh yeah, I can see it's returning like a three-dimensional vector. I'm just like not sure of the why of all like this stuff here. Actually, we did just read about Perlin noise. I don't know what goalies is. Because yeah, that's true, Max. Probably there was just a lot of experimentation and just kind of messing with stuff. Do wizards use Merlin noise? I bet they do, Flofi. Oh, the music stopped. Uh, uh, uh. Oh, you know what? Let's go with that song. Ooh. Oh, you did Penbox. How much of it have you gone through? This hash is not production ready. Please replace it by something better. Ugh. Haven't even. Oh, classic. Shaders are also kind of nice for drawing fractals naively, because you can easily run some competition. You can easily run some competition easily as fast for every pixel. Ooh, okay. Like, there's so many things that I want to learn still, but I do want to get into fractals. I've heard of Voronoi. I don't know if that's the type of noise though. Let's see. Mandelbrot set. I only know of the Mandelbrot set out of those. Ooh, that's trippy. For water textures. Mmm. I Wind Waker had very unique water too. Like, right, its graphics in general were like really interesting. Wind Waker and Shader Toy. I don't see a search. I mean, we can just Google Shader Toy Wind Waker. Oh, it's hidden behind. Why is my browser freaking out? Please stop. That. Ah. Okay. My computer is really unhappy with me right now, apparently. I I think I'm experiencing that. Let me try it from Google. Ooh, okay. That's cool. That's 2 to 3 more layers. That is some good water. Main Ross and Julia said you have some function you apply repeatedly. Interesting. Oh, Discord spammer. Come on. Half the people who freaking join my Discord server these days are just hacked accounts. Okay. Let's see. Mandelbrot set. At least this time they actually spammed while I was still awake and not at 3 in the morning my time. Define the complex plane as the complex number C for which the function f sub c of z equals z squared plus c does not diverge to infinity when iterated starting at z equals 0. Iterated over what? Oh, like composed with itself. Huh. Number of steps until it diverges / escapes beyond some bound. Cool. Directly related to the area research? Ooh. It's even cooler, Lofi. You iterate group homomorphisms. Oh, this is a way cooler one. I like this one. The Mandelbrot set is like the one I always like think of, but this is this one is pretty. Burning Ship Julius set? What? That's crazy. It does look like a burning ship. It is. Okay, let's see the thing that... This might be the last shader toy I look at because it's kind of killing my computer. That is cool that they're able to do it so succinctly, though. For the Mandelbrot set. See what the Newton fractal is. That's not bad. I mean, that the burning ship fractal definitely benefits from taking some liberties with the coloring. This one's a lot more like plain with the coloring. The shape is pretty cool though. Like, how do you make that shape? Oh wow, because it kind of looks like Newton's method. Huh. When there are no attractive cycles, divides the complex plane into regions G sub k. Hmm. For the Newton fractal, you have some complex function, use some polynomial like fx equals x tan minus 1, apply Newton's method repeatedly, the color corresponds to the zero it approaches. That's a lot simpler way of saying it. Technically, it's not a Julia set, it's a similar idea. Yeah, they mentioned Julia set for a certain type of function, I guess. Cool. Ooh, here's some cool ones. This looks like an octopus with only, I guess, 6 legs and tentacles. Yeah, exactly. That says a lot going on. Ooh, that's a cool one. Oh, I have this as just like the choice of coloring. Oh, this is wild. Okay. It's always so strange to me that Mandelbrot has some sections that resemble the surface of like oily water, or and this one we just looked at looks so much like soapy water. The Mandelbrot set, I would need to look at it again. I think I can kind of see that. Was there some sort of scattering fluid? I wonder if there's any relation. I don't know. I'm trying to like recognize a PDE somewhere in this like caption here, but I'm not reminded of one. Okay. I mean, that'd be great. That'd be a great way to win $1 million. It was so obvious the whole time. Okay. So again, feel free to distract me. But in the meantime, I'm gonna go back to this puzzle. So I need to figure out what this thing is actually saying. So we have 4 vacant spaces on the left. Move the checker so that all the white ones will end on the left. So like, do we want white, white, white? Followed by all the black ones. I think that's what we want. We want 3 whites and then 3 blacks. Checkers must be moved in pairs, taking 2 adjacent checkers at a time, without disturbing their order, and sliding them to a vacant place. Oh, okay, so you take this pair, move them here. One. Wait, do you do that? No, you probably don't do that. Uh, I feel like this, you need to do 1 step backwards and then 2 steps forward, maybe. Hey, Famished. What if I just took this pair and moved them here? Hmm. You know what will make this easier? Get a thing of just that. Oh, you know what? Even better. We can have a pair of those, and we can have a pair of those. Now we can swap things around. Okay, so If I take, I don't know. So we don't want to, if we do leave one isolated, we want to leave that one isolated. We already tried this pair though, and I got stuck. So what if I just randomly, well, I don't know. I can't imagine this is going to help. Let's just try that pair there. What do we end up with? We have one of those. Vacant, 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 vacant. I don't think that's helpful either. Or is it? Could we do these two things here? No. That's not helpful. So that's not in the play either. Maybe we can never move this pair because we would leave that one isolated and we can't ever rescue it. You think it was a good first move? Let's revisit it. What, could I move this pair here? I'm using more than 3 moves though is the issue. Like I think that this could solve it in 4 moves, and maybe that's a good start. Actually, I need individual pictures too. And then we have 2 vacants. White dot, 2 vacants. Oops. And that. So this is 1, 2. We're about. I think this is going to be a 4 moves solution, but I think we can at least start with that though. Oh wait, no. This is way more. I thought we could swap that pair and that pair, but no, we can't. I mean, I guess that's not an equivalent problem. Never mind. Okay, so this is many more than just 4 moves. That's like 6 moves. So we gotta like use these vacant spots to do some swapping. So that does solve it, but not efficiently. Well, okay, so we could come back to, what if we did this? Get the first spot just locked in, and we never have to worry about it again. Uh, Then what? We take U over here. I think this is going to be not 3 moves either. Wait. Oh. I'm missing... No, I'm not. What am I... I don't think I'm missing anything. No, this is bad. I don't think that works either. Oh, Max made a shader toy a while ago. Just sine curve. I remember those. Those are kind of strange. Can look kind of cool for some points. Ooh, that's super cool. Copy paste on the website? Okay. Hopefully my computer doesn't die. Oh, you know, it's okay. It's the home page that crashes. Oh my god. Okay. Not Chris said it's related to hardware acceleration. Let me turn that off. Where is the advanced settings? Okay. Thank you, Max. Just let me skip past the homepage. I probably should have tried just guessing that. Because I was trying to click on the new button and it wasn't having it. Trust memes, any good aptitude books resembling to patterns like the SAT, TSA, and all? I don't know of any, unfortunately. You'd have to just do some Googling. Ooh. That's cool. What is the clicking doing? Yeah, sorry, I don't know of any offhand. That's awesome. Function is f equals sine 1 over z plus c, where c is the mouse position. Oh, okay. That's cool, because it felt like I was like rotating in some way, but I knew it wouldn't be that simple. 3 moves. Have I heard of Acklam's algorithm? I have not heard of it, no. I can Google it. I hate that he's like looking down at the website. It makes me uncomfortable. I feel like he's looking over my shoulder. Oh no, he's following me down the page as I scroll. Ah! Inverse normal CDF? Huh. I can imagine that it's probably a pain to compute uh with like default methods. It's not a pain? Or like I assume that the algorithm gives an easier way than like the alternative. But maybe not. Fringe, the math must flow indeed. Pseudo-random numbers that follow normal Gaussian distribution. Oh yeah, sure. There's no closed form for the inverse normal CDF. People wanting to generate normally distributed random variables usually resort to algorithms like Box-Muller transform or the polar method. This one's surely good enough for my not so serious needs. There's something elegant about the inverse CDF method that just better fits my taste. There's no closed form for the inverse normal CDF. Yep. Not sure what these coefficients are doing, but let's keep going. What? Are we dividing up the Gaussian distribution into like... Are we dividing it horizontally? Like... Okay, yeah, so... We're like taking a piece like that, and then like a piece for the bottom. No? Okay, so I'm glad I'm drawing this out. So... Right. So I guess what I was imagining in my head was like, we want to specify an area under the curve. I know it's not the CDF, and maybe I should just draw that because that might be where my confusion is happening. I know what we want. We want to say like, we want to give an area underneath the curve and find the x value such that that happens. That's what we're asking for. But it would be better, as you're saying. I don't know what the CDF actually looks like. Actually, I can guess though. It would surely, most of the action would happen by the origin. It probably looked like a sigmoid, I guess. The CDF. Let's, I guess, check that. Okay, yeah, it does. Um, and so it's still like the same task. So in this case, we want to specify a y value and find the relevant x value. And so we're dividing this CDF. Okay, and so thank you for telling me that, Felix, because I was trying to imagine it in terms of area under the PDF, and that was not serving me well. um, so yeah, the CDF, we're using, I guess, 3 different polynomials, one for the lower part, one for the middle part, and one for the upper. It's actually, this exact kind of thing came up in my asymptotic analysis class. Like, not the exact same thing, but the same idea, where you have like areas of rapid change that need to be represented on their own. And for Max's shader, the colors are the RGB values. One over the real part, one over the imaginary part. Where's Z10? Or 1, 0, or 10? Okay. By one gets up to 10 iterations of Newton's method. Setting the coordinates of the pixel. Scale, so there's zeros in the middle of the screen. All points 1, I minus 1 minus I are visible on screen. Ooh, okay. So yeah, it makes sense that like one polynomial probably isn't going to do a good job for all 3 of those sections to me. Um, I wonder, are these just Taylor series for how we obtain these? And then you solve the problem to invert a polynomial, right? They're from Taylor? Okay. Like, if this is a potentially 5th degree polynomial, that's not easy to invert, isn't it? They're just doing it in one line here. Rational approximate. Oh, yeah. Am I missing something? Is it easy to invert a polynomial? Hmm. What if we invert the Mobius strip? I don't know. I assume you get a Mobius strip out again. I don't know. Need to use a numerical approximation kind of thing to estimate the CDF due to no closed form. Oh, so yeah, okay, actually obtaining the Taylor series will probably be pretty difficult then, right? Um, you've been going crazy with quasi Monte Carlo. Oh, and so that's why you're okay, and so that's why you might want a normally distributed random variable. Hmm. I wish there's a better explanation for it than just this one. That website is good enough, but it doesn't provide all the it's like okay, it's not coming up on my Google search at least. You need archives. Oh, so you have to go through like Internet Archive. Wait. Oh, nice. Thank you. Don't scroll past this. You can't tell me what to do. The inverse. Okay, yeah, right. Oh, so we're doing it. Okay. Yeah. Oh, yeah. What's up, Winklebot? Oh, okay. If you shift it, it's an odd function. Sure. Yeah, it makes sense that tails would have the same polynomial, just reflected and translated. Hmm. Ooh. Why? That's so interesting how it looks like sines and cosines, but kind of compressed. Oh, okay. He still doesn't talk that much about the math of it. That's what I was hoping for. Yeah. Oh well. Okay. I can't remember how to do Epsilon. Oh god. When we have a quadratic term, you have to handle both positive, and I have to go back through and do it. I've done this before. Um. Thank you for sharing that, by the way, Felix. So if you want to do the limit as x goes to a of x squared equal to a squared, like you want to prove that. What does epsilon delta say? For all epsilon greater than 0, there exists a delta greater than 0 such that um, for all x with x minus a less than delta, um, x squared minus a squared is less than epsilon. There we go. That's the epsilon. Yeah, thank you, Wigglebot. I f of x minus L. Right, yeah. And actually like, plugged it in, but close enough. Um God, how do we do an Epsilon-delta proof again? We probably want to factor... because we need to figure out what our delta is. That's the ultimate goal here. In terms of epsilon. I'm going to say is smaller than delta. Well, that's not good. That doesn't go the direction that we want. Right. Same here, Winklebot. It's maybe been 2 years for me. Um, dur, dur, dur. Okay, do we have to do a thing where, like, if x minus a is less than delta, can we bound x plus a? So do we need a trick like that? I forget how this works. But then, like, the inequality might still go the wrong way, though. Into cases, that's right. Yeah, that's how you can deal with that. Or like you can say like delta, like you can take delta equal to like the minimum of 1 or epsilon or some garbage like that. Or this might be premature, but like you can you can assume that delta is less than something. Or like do 2 cases. I kind of want to Google this though because I feel like I'm gonna screw this up. The band within the neighborhood. Yeah, I think I'm going to do the shameful thing and just resort to Google because I'm definitely gonna mess this up. Sorry. Wait, do you not want spoilers? This is just the person's like thoughts, so they may not be right. Go for it. Okay. Yes, syntax error. I'm pitifully bad at epsilon delta proofs, and Winklebot is asking if we can do it for x squared, and the answer is no. I can't do it, but someone can. X squared minus 4? Oh, so just to get the limit to be 0? I don't know. I was trying to do the general case. I'd rather do the general case. If we can figure it out. Huh. How do we get this? Oh, this is just inequality magic. You can just slam a -2 in there for free. So you can make it as small as you want. Where the hell does this line come from then? Yeah, something like that, Winklebot. The general case and limits. What? Oh, wait, this is all one line. Oh my god. Okay, let's see if we can reproduce that. Uh, so I guess I was off to a bad start. No more absolute values. So yeah, we can add a squared. We can... That's what the limit is, yeah. We're starting with this statement here, so it should be the square of whatever x is approaching. Yeah, absolutely chime in syntax. Well, yeah, but then this needs to be a root a over here if you do that, Winklebot, and that's fine. Uh, it just needs to, like, you need to adjust your x value too if you do that. So actually, I mean, we can just do that. Makes you happy. Well, I mean, a is just a number. We can square it or not square it. If we choose t properly. I don't know how to choose t properly. I guess we were kind of talking about that, but I don't know. Oh, so you know, this person just takes the positive square root and doesn't worry about it. I assume you technically need to do two cases for negative and positive x. Uh, improve x squared to continuous, you can't really use square roots. Well, tell that to Stack Exchange. That is kind of a good point, though, syntax. I don't know how to actually respond to that. Oh, wait. Is this tech? Wait. What do we do with this? delta. This seems good. I think we can just plug delta into that. Okay, changing gears again. Let me do that a little bit slower. I'm gonna say it's just magnitude, it shouldn't matter. I think it might matter. Oh wait, this is triangle inequality. Ooh, greater than? Wait, less than. Okay, let me be clear that we're using triangle inequality here. Then we distribute. And then x minus a is less than delta, right? So delta squared plus 2a delta. And I think we just set epsilon equal to delta plus, or we set it, and we solve this for delta, I would think. Are you Jar Jar Binks? Misa fool? Do we quadratic formula this? This feels messy. I wonder if it cleans up though, and if it gets the right answer. I'm not above it. I don't know. I don't think that was the right. That's probably not the right answer. Wait, is it? It's not quite the same as this. It looks really close though. Wait, I think I did make a small mistake. That should be a plus. Wait, so I guess we take the smaller of these two things, which would be the minus case? I still think this is wrong though. Okay. What does this solution say? God, I hate Epsilon-delta. Oh, so this starts by squaring. This does it. This is the Chad wave starting with delta. That would get around syntax errors issue with square rooting. Boo to analysis in general. I love that you like there's no type of math that you don't love except for analysis. That's the one thing it's like you will not show love to. Still like it, just less. Okay. So this in our yeah, this is what scares people away from calculus. I got to avoid it in my calculus classes. Thank God. Wait, this is the same quadratic that I had. We assume delta is less than or equal to 1. Wait, is that the same quadratic? No. Yes, it is. Then delta squared is less than delta, so they can be bounded by 5 delta. Choose any delta so that delta is less than 2 and delta is less than or equal to 1, and 5 delta is less than epsilon. Okay, that is a lot easier than trying to do some quadratic formula stuff. Well, okay, my work up here doesn't explain why we would want epsilon greater than this thing. I don't think it does. Oh, yes it does, I think. Because we did start with this thing being less than epsilon. And so if it's also, if x squared minus a is also less than this, then we're certainly meeting the less than epsilon. Okay. I guess strict to greater than, it's not a big deal. Delta is less than 1. Delta squared plus 2 alpha delta is less than 2a plus 1 delta. So that inequality goes the wrong way, doesn't it? Dude. Wait. I don't know. This inequality doesn't go the right way to be used with this inequality. I don't know. Wait, but it's getting flipped? I don't know. These proofs kind of require you to know the answer and then work backwards. They really do. Analysis in the branch of math consistently makes you able to sympathize with other people in the world who don't like math. All the other branches are nothing but fun. I like analysis except for Epsilon-delta. I make an exception for Epsilon-delta. At the end of Calc 2, when we talked about radius convergence, monotonic convergence theorem on the number line, it made more sense. It's, again, lost to you now. Did we induce PTSD? No, it's fine. I really should understand this. Like, the best thing to do would just be to get good at it. And it won't bother me again. But I hate it. Why does... Wait, no, the inequality does not get flipped. We want to name a delta such that this quantity is smaller than epsilon. So why are we using a bigger quantity? I don't get it. Well, yeah, this is saying that the limit converges. This is like the very essence of what it means to converge. So yeah, like that's like a good thing to like think. Um, like this annoys me because it's such an like an important and big idea in math, and it's just so annoying to actually do it. The squeeze theorem almost killed you. I guess actually using the squeeze theorem can be tricky. Actually, oh yeah, the first time you learn it for sure. Yeah. Oh, and also you did have some crazy problems you had to do too. Yeah. Yeah, okay. It's like the statement of the squeeze theorem is great and I love it, but actually using it, yeah, it is kind of like Epsilon-delta stuff where it's a lot easier to understand the statement than it is to actually apply it to something. Um, you know what thing you can squeeze between? Right. Trying to ram your head against find anything to squeeze it. Yeah, yeah, exactly. That is rough. Okay, this is the explanation for the I always get so confused. Like if you have a bound for x minus 2, I always get confused on how you bound something like x plus 2. This is the way I need to see it written, I guess, because this makes sense. Um, so that means you can bound x squared minus 4 above by 5 times x minus 2. Sure. So if x minus 2 is also less than epsilon over 5, okay, you're glazing over the one part. This is where we choose delta equals 1 as a test. Yeah, I think so. X squared minus 4 is less than 5x minus 2. Okay, this does get to delta less than epsilon over 5. I think the quickest that we've seen. Yeah, I think this is my favorite answer that we've seen. That min works wonders? Yeah. Because I was wondering, like, if you made it like, what if it was less than 2? But if it's less than 2, it's also less than 1. So the same logic works, and that's why the min 1 thing does its magic. Oh wait, no, never mind. It's less than. Never mind. Oh my god, I never. I completely said. Ugh. I think it's that syntax or like something like that. If we want to do it the general way. Yeah, I. The good news about Epsilon-delta is that you only need to do it for like the elementary functions, and there's only like 12 of them, and then you're done. You never need it again. Everything else follows from those fundamental proofs. Okay. You're a fan of fundamentals? They are pretty fun. Okay, assuming that's good for your question, this might be a good time to wrap things up. Like, I could keep working on the checkers problem. I don't know if I want to, though. Oh my god, 1 over x. 1 over x for the epsilon-delta limit? I remember being an especially annoying one for me that I think I still don't understand. Like, just for, like, a finite limit, not even, like, worrying about infinity. Or, is it easy? I remember, like, you have to do a similar thing with, like, letting delta be less than 1 or something, and I never understand when we do that. But 1 over x in general is such an important function, and it comes up, like, over and over again. Yeah. Like, 1 over x becomes super, like, it's an underrated function. Like, in complex analysis, you do the 1 over z transformation all the frickin' time, and understanding what that actually does to the complex plane is important. And even just in good old calculus, 1 over x is like the magical critical breaking point where the area under the curve either converges or diverges. So in 1 over x it diverges, but as soon as you go slightly faster, you start to converge. Conics FTW. I can take or leave conic sections, to be honest. 3 points 1 over x and ln x. Yeah. Those are how they get you. These checkers are cursed. You found that the other alternation is simple, but black-white is impossible? Really? It is. From Moscow Puzzles. I just kind of randomly found it from Googling books because I wanted something to use for filler time on the stream. That doesn't require like calculus or any advanced math. And so it just seemed like a good thing to like try out. Syntax error, working it out fully. Boom, boom. That'll be at most one. Okay, nice. Clap cert for you, Syntax. You don't know if it's impossible, but it feels impossible. I have not been able... so I've been able to work it out in more than 3 moves. Aeneas, I cannot work it out in just 3 moves. One point for getting an A in your limits class? Oh, that's painful, Syntax. There is an answer key in the back of the book that looking at the answers, if you don't have a solution, just feels so against the spirit of doing puzzles. So I'd rather not. Converge to a B plus. You think you got it? 2, 3 to the left. I assume all the way? I think I investigated that. Maybe I did it bad. Oh, okay. Then you're saying, get rid of this. 4 and 5. Oops. I guess like these two. Here? No. You can't do that, though. We don't have vacant spots on the right. I don't think you can. So we have 4 free spots on the left, and that's it. So that's how I'm interpreting, like, that sentence there. I think the slide isn't a... What? Sliding it is the move, I thought. So you were... I'm so curious to see what you were going to do. If we do cheat, then you would have that. Hey, it's almost there, but I don't think you're doing this in 3 moves. Yeah, Anis, I agree. Now white to far left. Oh, I see. Okay. I think they have to, I assume they have to be touching too. But yeah, I think we're adding slots that we don't have by doing that. It does have a lot of trick stuff? Okay. Like, it doesn't seem very possible to do it with the constraints as I understand them. So maybe I am misunderstanding something. So if they don't have to be touching, like, it doesn't say that they have to be compressed in one line. Can we use that to our advantage? Like, we can have spaces between them. So that seems like a little way we can 5, 6 all the way left. I was just thinking that, like, we need to deal with this thing on the right side. So I like this as a first move. Now, the only... This is annoying. I feel like this is a good way to get black on the left. One second, let me see. Yeah, it's 3 moves is killing me. Hmm. I want to look into this because, like, this white checker being all the way on the right seems like a big issue. But then, like, I don't know. 4 or 5 left? Let's try that. 4 or 5 left. Then 1, 2 in the gap they made. So I assume over here. I don't know if that's gonna work. Because we can't get rid of the, like, the black one in the second spot is gonna kill us. Or, wait. I think that's what we get. But I don't think this is good. Dr. Cook, how's it going? Good to quote unquote see. You must be on your summer break, right? White, far left, but that's our third move. And this black one here is messing everything up for us. You just goofing off. Haven't thought about math and physics in a month or two, feeling guilty. I mean, you got to take a break sometimes, though. Hope that your job is still going well. 2, 3. Motivate you, please. I just been doing I just when I was been a question, I've just been doing like puzzles from a book called Moscow Puzzles. This one has been challenging all of us. Wait, so Winglebot, are you starting from scratch or picking up where Fembox was? You have to move the first pair so far. You could have left 2 empty slots from scratch. Oh, okay. Let's do Winklebots then. That's true, Cook. You do need to write an entire textbook and then give us an entire course. If that's not motivation, I don't know what is. 2, 3 left. I assume only a little left. All the way? Okay. Let's see. TVSR. Someone asked me they want to learn math from scratch. Person struggles with pre-algebra. I'm not sure how to answer this properly. I was wondering if you could help me. They asked, "Will take realistically take for someone to get from base math to solid advanced level like calculus? What's the best way to measure progress along the way?" I would say, like, just find a couple of textbooks. Like, OpenStax is great for that person's level. And they can measure progress just by their progress through these textbooks. For how long, it really depends on the person. Like, they can start like at elementary algebra. And to get all the way up to something like calculus would be like years, though. It's kind of it's a process if they're starting pretty much from scratch, like the way it sounds. No, we only have these 4 slots available is how I'm interpreting it. So we cannot go right, we cannot go more than 4 left. You're teaching GR in the fall from Hartle? Noise. Well, you can only go right if there's like, if you left a vacancy earlier. Let me, wait, so Winklebot said 2, 3 left. I did that. 5, 6 to the gap. So 5, 6 here. No, did you do it? Or am I thinking of the wrong gap? Let's. So it goes black, white. No, it doesn't. Black, black, white, white. No, this isn't three moves. We've already looked at this, I think. Unless I'm doing something wrong here. Oh, it can't go that far left? There's no space rightward of the initial 6th checker. Correct. That's all good, Winklebot. Could this gap be better? No, okay. No, it's not better. The first move is not all the way left. Okay, so if this is 1, 2, 3, this is 0, -1, -2 is the Fenbox number line here. Okay, so Fenbox is saying 2, 3 to -1, 0. Okay. Maybe I should just keep these all like individual like this. So 2 and 3. So we're gonna have a white and the black, and then another black, and then a 2 gap, and then white, black, white. And then Fenbox is saying 3, 4 to -3, -2. Okay. This is what? No, it's 5, 6 to 2, 3. Okay. Okay. Cylinder Monkey, hi. I appreciate you saying hello. How's your day going? Currently racking my brain over a puzzle. I think Fembox just did it though. Wait, did you do it? Wait, no, I set this up wrong. I set this up wrong. You said 5-6 to 2-3. So these two need to swap. There we go. Oh, okay, you did it. Oh my god. Nicely done, Fembox. Holy crap. So what, you did that? That. Wow, that was so... I didn't realize that one would be so hard. Okay, so sorry that I'm behind on chat here. Let me hot. It was hot AF and I sweated a lot. Other than that, today was great. Noish. Enjoy your dinner. I appreciate you saying hi. TVSR, I didn't I must have missed your message. Okay, I missed it. I'm sorry. TVSR pre-alg, elementary algebra, intermediate algebra, algebra trig, pre-calc, college algebra. I don't know what all those mean, to be honest. It could be a good path. Like college algebra, I don't know where that college algebra, like depending on what that means, you might be able to just drop that. But other than that, that seems like a good path. Sudden pain in my chest appears from this problem. The Fembox underline has a nice ring to it. It does. You ever program with MATLAB? Oh, for Fembox. I remember the one indexing in MATLAB. That was a nightmare. I hope I haven't missed anyone else's chats. If not, please yell at me. My master's is done. I graduated in mid-June, Dr. Cook. I'm currently applying to jobs now. Helped an engineering student, some numerical, now some MATLAB. Some other stuff, I don't really know it. Okay. For the MATLAB thing. It can take years for the person. Yeah, I'd say easily years if they want to learn it well. Yeah. If there's some sort of genius, then maybe they could do it faster. But for a normal person who has a life and other things that they want to do, like years. Thank you, Dr. Cook. God, I wonder. Like, there's surely a combinatorial interpretation for a problem like this, right? I feel like I'm making a hard problem even worse by even saying that. Thank you, Max. What kind of jobs am I looking for? Do you try the application cycle during your last semester? I did not do any job applying while I was in school because I was way too stressed out. Just with my schoolwork and barely keeping up with that. Am I rich? No, I'm not rich. I'm trying to get a job as soon as I can because I'm gonna run out of money soon and have to move back in with my mom. So the hope is to get a job before that happens. No, I was basically an HR person. It was like a well-paying HR job though. Software engineer. So and so kind of my issue is that like that's my only real job experience is being an HR person doing administrative work. I don't really want to do that again though. So the type of jobs that I want is like, well, the dream job would be doing, it's called like bioinformatics analyst. And it's basically data analysis in the biology context. And so the first place that I applied is a place where I'd be doing data analysis in support of like cancer research, which would be really cool. I'm not really qualified for it, and I don't think I'm going to get it, but I'm working on. I have an idea for what I can do for a project that would make my application better and hopefully help me get it in the future. When I met you guys, I was unemployed for the first time in my life. It ended up lasting 9 months. Plus, I had to take a bad job first to get out. Before this job's like 15 months, including the shitty tide over job. I remember that. Hey, you know what, Dr. Cook? You can make your glorious return to streaming over summer. 9 months to practice waffle stomping? Yeah. You know, you said you're feeling demotivated and you want to do math and physics, so the people demand more Dr. Cook streams. Demand is high, supply is low. You have them right where you want them. True. Ugh. That's just economics right there. Oh yeah, that's right. He was talking about Clifford algebra. The big red algebra. Okay, I don't want to do. Oh, this is like one of those Facebook puzzles. Okay, fine. We'll do this one because it's just counting at least. 1, 2. Okay, wait. Maybe let's take a screenshot. Sometimes you gotta do the slug routine manufacturing commercial cleaning for 10 plus years, middle age, and in school, hoping to get my master's by 34. 34, you dick. Okay, if you're saying you're middle aged at 34, that feels pretty pessimistic for how long you're gonna live. According to Dante. I think of Dante's Inferno. Or maybe, I don't know, or maybe you mean Dante from Devil May Cry? Or that, like, the actual Dante. It is Dante's Inferno, okay. He was 35 and he called himself middle-aged. People died at 40 from a toothache. True. Yeah, sorry, Fembox. Meanwhile, I'm basically a child at 29. And I'll never be old, ever. And people always, no. I'm not old like you, Dr. Cook. So I think the trick with this is people always miss the big triangles. Now that was intentional. Yeah, it was. I haven't actually been counting. It's kind of a problem. I've just been coloring things. What do you mean by different triangles? What about congruent triangles? I guess we'd have 3 sets of congruent triangles. Are these all 5 triangles each? So we have 15 triangles? Yeah, I think we have 3 sets of 5 congruent triangles in this picture that I see. That feels like it's not a coincidence. I guess when it's a regular polygon, like, you kind of have to be symmetric. Like, yeah. So 7-year-old kid ran up to me on my walk today. He wanted to tell me very bad that today was his dad's birthday. How old is he? The kid goes, 32! Aw. Feels bad. You see more? Really? Oh! Damn it. When you're right, you're right, Winklebot. Okay, so we're saying there's 20 sets of 5 congruent triangles then? Are there even more, though? I don't think so. They're all 5. There must be a reason why they come in 5s. I guess because you're removing one vertex? Kind of feels like even more? It does suck, doesn't it? Reflect that green one on its longest side. Oh my god, Fembox. I'm running out of colors here. You're doing that. The triangles just keep coming out of nowhere. So 25 we're up to. Do we get the pentagon edge ones? This thing is kind of a mess of colors. Maybe I should just color one from each of these sets, and that would be more clear. Yeah, I think our count is up to 30 now. Wait, is there? No, I think I'm only up to 25. So we have that triangle times 5. We have that triangle times 5. We have that triangle times 5. We have... Well, I guess I can still do it on this one, and then I'll switch to the other one. This triangle times 5. And then we have this triangle times 5. 35? Oh. Okay, I think I see another one. No, I don't. Blue plus red. Oh my god. clockwise and counterclockwise. Bruh. That's so sneaky. That's a nice... I like this orange. I'm officially out of colors. Actually, no, there's custom colors. Dark green plus blue. Okay, yeah. Oh, wait. Oh, you said blue and red. Wait, blue and red. Yeah, so my mind immediately went to what Winklebot just said of dark green plus blue. What's blue and red? Trying to... Oh, okay. Yeah, so what's our count now? We have 7 times 5 is 35? Okay. Oh, you are colorblind. Okay, that makes it harder. Why does 7 show up and a 5 gone? I don't... Yeah, that does bother me. 5 is 1 less than 6, 7 is 1 more than 6. Wait, this is a pentagon. I thought this was a hexagon. I don't... Why did I think it was a hexagon? Did it have something to do... I don't know. I feels like there's a graph theory explanation for this. I do want to check the answer for this one, because it might explain something interesting about this, and we might have missed more triangles somehow. Stands with Euler's ghost? Maybe. Probably a pattern for the n-gon. I bet, yeah. The square... Yeah, I guess this is all the diagonals. So this is like a fully connected graph. I don't know enough graph theory to say anything about fully connected graphs, though. You think you see more? The plot thickens. I'm about to go look at the answer to see if we found them all. Red 5, light green 5, dark green 5. Make a triangle. That I don't see a 3-sided shape in that. You have all the vertices formed. See which of the trios are valid triangles. Look at the spaces they're enclosed in. So this, like, you're basically deleting that triangle and that triangle. That's the shape that I'm seeing right now. That from what you said, Winklebot. It's like the lower left corner is intact. That side is intact. Then you suddenly have like this. Looks like a boat, I guess. 5 to 2. The intersection of 3 and 4. Oh, I think that's our magenta. No, you're good, you're good. You have interior vertices from the intersections too. Okay. Yeah, true, Cook. True. We'll get rid of these fives. This graph is not fully connected though, if we do this convention. But yeah, you're right. We do need to make those nodes too, because they are valid vertices. Hey, Echo. The question is just to count all the triangles in this like picture. It's like one of those Facebook quiz questions. There's a lot of them though. We're up to 35. Ignore the other stuff that's happening on the screen. It's not. Light blue is a 283 right triangle. I agree with that. Capital letters for I can get down with that convention. Like we can do small n, big N. Actually, yeah, that's better. A. We have to make a choice here with where A goes, I guess, or like small a. You can see 40. That's quick. It's possible we missed one. Or like we missed a set. You can't see any other triangle without going crazy now. Yeah, it is very possible that we missed some. I thought this one would be just be like a quick one to end the stream on, but it turns out this one is a lot deeper than I thought. And like I feel like this has to be leading in something that's more complicated. Like or like we could relate this to something cool in math. That's what I'm looking for right now. Like I'm looking for like graph theory or linear algebra or complex analysis. Okay, Echo sees EDA. We have that. EDE. We have that. EDD. We have that. EDC. Electric Daisy Carnival. We have that. EDC again. I think we have that. EDB. I think we have that. ADB. But I don't know how to count. Oh, and E-E-D-E. E-D-E. Wait, what do you have that I don't have? You have 1, 2, 3, 4, 5, 6, 7, 8. Wait, which one do I not have marked? Because I think you... Or did you double count something? EDA is my red. EDE is my... one of my oranges in the upper right. EDD is my light blue. EDC. I think you might be counting... Wait, no. I don't know. Capital EDC? Wait. Okay. No. Echo, yeah, you double counted EDA and EDC for all caps. Yeah. There are only 10 that include the central mini pentagon. That is a nice word for it. The central mini pentagon. There are only 10 that include the central mini pentagon, which is like my magenta, which I shouldn't use colors. We should use the vertices because of colorblind. Yeah, it's like A, C, D include the central mini pentagon and ECA, for example. Through the mini pentagon, it's easier to count potential triangles. You have a theory based strictly on a guess here. We enjoy those, Winklebot. One triangle, 8 square, 35 pentagon. Oh yeah, what's the sequence? But I guarantee you that's in a OEIS though. OES has everything. Well, this is a funky thing. I don't think it's what we want though. These are scary. It might be equivalent to one of these. I don't want to do the work to figure it out though. Ooh, I don't know what a wild group is, but that feels like something that could be related. Mahonian Bizbuzz, hello. How's it going? Okay, wait. What if I do Control F Polygon? Polygon. Polygonal polynomials. Upper right, different triangulated planar polygons with C plus 2 vertices. I don't know what that means. I'm moving past it. Oh, those are the only 2 polygons on this page? Oh, there's 103 results? I'm not looking... Okay, you know what? I lost interest in OEIS. This is too many. We need some more numbers in the sequence if I'm gonna do this. Okay, let's look at Winklebot's conjecture. Pentagon divided into triangles. That's 5 edges minus 3 edges. Or 5 edges, 3 edges? I don't know. With an additional pentagon adding 5 edges. We have 5 minus 3 plus 5 edges. That's 7. I don't know what you're doing with that Winklebot. Or it's hard to understand, like, I don't think if subtracting edges is something that we would normally do. Like that. But maybe. It does get 7. ChatGPT says hexagon is 110 triangles. That may be the correct sequence. Oh, the one out of the while group? Oh, the top sequence? Okay, maybe. Catalan's triangle? Hmm. I really want to look at the adjacency matrix. It's what I always do with the graph theory, but I'm willing to make this 10 by 10 matrix. I want to know its secrets. Take a polygon, nest in another polygon. Whatever shape you want to cut it into, you get you get pieces equal to the number of sides in the polygon. Well, I think I think it only works with triangular pieces. I can't imagine you can divide this or like this pentagon up into squares, if that's what you're saying. I don't know the terminology either, to be fair, Winklebot. Oh, I mean, yeah, that's fair, Winklebot. I just wanted to understand what you were saying. You don't have to be right. Echo, I like the way you think. Let's actually do that. That is better than what I came up with. I mean, once I see what this matrix looks like, I might want to change, like, shuffle the columns around anyway. But not having done that yet, that's a much better idea. Okay, so capital A, we're going to say the nodes are connected to themselves. I mean, that's not actually true. Never mind. I forgot. You can actually have nodes. Yeah, okay, never mind. Okay, capital A is connected to capital C, is connected to capital E, B, D. Oh yeah, okay. So um we're gonna have a bunch of ones in this section because it's fully connected. I already messed up the letters. A. I would believe you. A is connected to small c. A is connected to both. A is connected to big C. And also small c. Oh, wait. Oh, I see what you're saying. Sorry. Never mind. I was moving through nodes. That's not right. Okay, thank you. That's a good catch. So it should be like that. For that part. A is connected to small d, small c. Okay, that's our first row. Greek letters, I'm going to stick with this, but yeah, I'm definitely confusing myself. That doesn't help that I've been doing math for 4 hours. When did it become 4 hours? God. Okay. Small, or big B. Klingon letters? If only I knew Klingon. 1. Okay. 0. Japanese at. Small d, small e. N choose 3. Huh. I'm using AI for that. I don't mind using AI for stuff like that. Like, I'm not going to believe it until we can find a non-AI source that confirms it. But it gives us something to think about. 101 for the hexagon. It's a triangle that is degenerate. Just a central... And really? I guess even polygons could have that problem. Like, if I can find a formula that matches... Like, this is probably some version of Pascal's triangle. I would believe that you can express as a combination of chooses. What row do we live in? Or do we live in a column? What do we say our sequence was? 1, 8, 35. We're right here. I wonder what could the other rows be other ways of subdividing? But like this is finite. I wonder if we start skipping around in this sequence, like if we have a subsequence of this. Because we definitely shouldn't, we probably shouldn't repeat 1430. In the second to last row, right. Shall we try the hex? I guess so. No, I don't care at all if you use AI Dr. Cook. I'll admit to using AI myself sometimes if I'm like stuck on a problem and just want something to like think about. And we've already answered like the fundamental question that the book asked, which is how many triangles are there? This is just like our own exploration. Plus, I also broke out OES instantly, which is probably even worse than using AI in terms of like spoilers. So 30. Oh, that's a good. Yeah, before we go off the deep end, let's confirm 35 was correct. Spoiler alert. I'm about to click on the answers section. So this is for number 5. Avert your eyes to the non... It just says 35 and nothing else. Okay. So 35 is correct. I was looking for some background. Um, I guess we could make a hexagon. Benlux is known to strike hard. It's called Moscow Problems, not Moscow Solutions. Ugh. Okay. Pop quiz. What angle does a regular hexagon have? Can I even rotate things in this program? I can. This is a little bit too freeform for me, though. If holding shift does nothing. Control? Alt? No. Higher 3? Makes sense. I don't want to draw this freehand. You know what? I have a much better idea. Google Images is our friend. Hexagon. Much better than drawing. Or trying to make one. What? My Journal++ just crashed. Okay. Well, turns out that wasn't such a good idea after all. Did I lose the work we had? It's not really a big deal. I think it does auto backups. I need to figure out... That's not what I want. Wait, why are you showing GIMP? There we go. I can only draw a square in this program. Where are the backups? Tools, plugin, help, ugh. Journal, ++, backup files, question mark? In app data? If I can't find it quickly, I'm just going to forget about it. Local temp. I have no idea what's in this folder. A lot of temporary files, I guess. Okay, I can't find it. I have stopped caring. Sounds good, Winklebot. Thank you for conjecturing and for the help with us with solving it. Oh, perfect, Cook. Thank you. Much better than mine. Actually, you know what? Let's do that. Yeah. We do have a lot more vertices. Well, the answer should be 110 or maybe 111 if you count that as a degenerate triangle. And so if we divide that by 5, that's 22 triangles we need to find in this. No gravestones soon, young gun. I did E twice. I'm a big fan of the letter E. How are we gonna do these? The middle ones. Okay, well, I'm just gonna do this. This is probably stupid. If someone's has a better idea. But now F connects to F. Ugh. Who cares? I don't have a better idea. Fuck me indeed. Showing general formulas, tedium dark calculation in this case would motivate the general pattern. Ugh. This is a lot of triangles. Hey again, Suna. Good to have you here. I guess we need one in the middle. We ended on L. M. I guess we're just gonna get to counting. Okay, and we don't necessarily need to find every last triangle, but what if let's start with this one. How many congruent triangles are there for A small e small m? If we don't, I mean, do we count the reflection or not? I guess we do. I guess there's 6 if we count the reflection. Oh no, there's 2 reflections. I was looking at this reflection here, but you can reflect it the other way too. So, oh god. So that means there's 6 interior. And 6 or you label it this way. Interior hexagon using lowercase letters, inverse as before, something like 0 for the central point, or O. The midpoint interior vertices may be labeled sensibly from the scheme. Okay. We can do that. Well, can we do that? With even polygons, we don't have an opposing interior vertex. We have the midpoints that are opposing. But yeah, I guess there's no reason we can't do that. Could also be same. Yeah, I mean, we were doing opposing, I guess, just to avoid connecting big letters with small letters directly. I guess it's not too important though. Suna, we're kind of going off the rails. I've been pulling puzzles out of a book just for like discussion's sake, and so we were doing number 5 about counting triangles in a pentagon. And we found the answer to that is 35 triangles in this pentagon. And we were curious about generalizing it for bigger polygons. And so on our own, we decided to look at a hexagon now. We think the answer should be 110. But we're basically... I was starting by looking for that blue triangle, but we want to count and find all 100. I mean, we might not want to, but at some point, we want to justify why there's 110 triangles, if there are. So I was just starting with the blue triangle, just to, like, choose one. Okay, maybe the sensible way of... Can we do double? Like, maybe this is stupid, but maybe we call this one AB. In this BC. Greek might be less confusing. Yeah, we can do Greek. Good luck typing that, but we can do it. Maybe we'll put alpha there, beta. Oh god, gamma. I'm already at my limit of Greek letter knowledge. The order is my issue. Alpha, beta, gamma, delta, epsilon. Of course. What is F? Zeta. Naturally zeta. Oh, that's like the worst one. Ugh. Oh yeah, phi is the F sound. I guess I should have said, like, in terms of the order, what takes F's place. Turns out it's zeta. I really don't. Kasai is the worst one. We'll make that eta. We'll just skip zeta. So, let me get the formula Dr. Cook put. And so this formula, Dr. Cook said, this formula apparently gets you 111. We expect the answer to be 110. But this formula accidentally counts the center point as, like, a degenerate triangle, was the explanation. This formula feels like something that could be justified. Like, n choose 3. We have 6 vertices, and we can choose any 3 of them. Okay, yeah, that one checks out just fine. I'm like, I can't delete the blue triangle that I made. There we go. So, like, n choose 3 represents these big triangles. Because we can just choose any 3 of the outer vertices and make a triangle that way. So that checks out. Like, ACE. If the bounding hexagon were not regular, central triangle would open up. True, yeah. Okay, and then 4n choose 4. That's harder. Would n choose 6 be easier to figure out next? Well, okay, one of these formulas is slightly wrong because one of these formulas is overcounting by 1. We do have to remember that. Or like one of these chooses. What properties do combinations have? Can we convert? Mmm. True. I don't know what it means for bigger polygons then. So honestly, we would really want to do something more than 6 to know what that term means. I don't want to do more than 6, but I think you're right though. Like, I don't know what else that would be. And so I wonder if that term would account for triangles and that have to do with the very center in some way. I'm hoping this Wikipedia page gives me an idea. Like, if you have n choose k, can you write it? Like, I want to make all these combinations base 3, like something choose 3. And I wonder if there's a conversion formula. Might be on the binomial coefficient page. Hurry up. Hurry up. There we go. I I don't know if this is going to make it better. Yeah, true, Cook. Euler's formula. As in, like, the one with the vertices and edges, echo, or like e to the ix? Or Euler did too many things. He has too many formulas. Okay, you're talking about the one with vertices and edges. The n-7 graph in Mathematica. Okay. Yeah, graph theory probably is the way to go for this. I want to learn some graph theory at some point. What's F again? You're hooked even though you have to go to bed. Faces. I don't remember what faces are. Graph theory is ultra interesting to me from an. Oh yeah, I've done a little bit of graph theory for machine learning, and like spectral graph theory is so cool. Imagine a cube, you lost me there. Oh, so you can't intersect edges if you want to count the. And so face is the number of areas if you draw them in such a way that there's no intersections between the edges. Hmm. So we want to count using the right side. There's only 4 faces. 1, 2, 3. Is the 4th face in this one the entire thing or just the inner square? We do 4th face is outside. Okay. So it's 1, 2, 3, and then 4 is outside. Okay. That's easy to forget. that okay. For a hexagon, that's gonna be a little messy to draw. By little, I mean a lot. A lot'll. Well, trying to make a planar graph for the hexagon that we have. It's impossible. Uh oh, so but you're saying that we could use it. I thought. Are you saying we can't use Euler's formula? I can't scroll up in chat. That's infuriating. Okay, I can scroll up now. We just have to make up the formulas for the amount of edges, how many non-triangles appear. Possible if you only count the. Oh. No, I think we're counting everything that I named. Oh, I forgot about the middle. Oh. Oh, true. Okay, yeah. I keep making the same mistake again. I keep thinking that big F is connected to big B, but it's not directly. It okay. Yep. I see. Okay. So And we know V and we know E, so we could use that to solve for F, is your idea. That could at best get us the small triangles, which actually is not bad. Because I don't know if it, like, these two terms here must correspond to the small triangles in some way. Some definition of small. There's like small and medium. And we're not going to count the medium ones either. What? But I could still get us a piece of the formula, potentially. Oh, wow. Dr. Cook. Those are thick. I bet Mathematica has some good graph theory functions that could do something like this. I barely use Mathematica. The few times I have used it, I've kind of raged at it. That's for a septagon. That's an octagon. These are crazy. We like decompose the whole thing in different subgraphs. Hmm. Maybe there's something. I mean, so I see. We need to answer the question of how do you find those fundamental triangles, but there is still like maybe the graph theory thing, like, or I don't know exactly, but like there's still an important question to ask after that, which is like, what do we multiply each of those fundamental triangles by? The n-6 which is degenerate for the hex. Yeah, I don't think we've answered the question of what n-6 means. I think we've only figured out what n-3 means. The others are still a mystery. Speaking of n equals 5, yep, Dr. Cook just sent that. Oh. Oh my god. There are too many damn shapes on this page. So we had 7 different fundamental triangles. I did, Echo. I feel like that's what you usually do in geometry. You go clockwise, even though everywhere else in math you go counterclockwise. Fake mathematician. I didn't even think about that, but yeah, my instinct was clockwise for some reason. You're right. I should have gone counterclockwise. It might depend. I don't know. I might just be crazy and making shit up too. All right, we can be we can be real mathematicians. It's okay. That's true. Probably depends on the country too. I think of the remaining triangles. Yeah, what does this formula give us for n equals 5? I still don't really know. So yeah, that's 0. That's 1. Wait, are we discarding the choose 5 term also? I guess we have to, otherwise the formula doesn't work. It's kind of lame. I'm not good at calculating combinations in my head. I'm just gonna go to Wolfram Alpha. 5C3. Wolfram Alpha did not interpret me correctly. Choose 5, comma 3. 10. Oh, okay, no. We do include a cook. 10 plus 4 times 5 plus 5 is 35. Okay. The Shin's new slang, I'll put that in queue. I don't have the song request like turned on, but I can pretend to be Nightbot. Add to queue. All right. Actually, you know, I'll just skip this current song. Well, you know what I always say, Dr. Cook? Making a mistake in math is unforgivable. I don't want to talk to people who make mistakes. Ooh, maybe Echo. That's a thought. Yeah, I like that. Um, how many triangles do we have with just 3 vertices? We have this and no other vertices get intersected, right? So that's 10 in total. And I feel like this 10 is already occupied. So maybe the 10 is hidden inside of this term, like collapsed. A class of 20 and a class of 5. The star arms are the 5? Really? What would distinguish these? So the big triangles are taken by 5 choose 3. Like, those are taken. Um, I mean, it might be Cook. I just don't know. I wish I saw my drawing of what all the different triangles were. I could redraw it, but I don't remember any of them being particularly distinct. I think it's worth it to redraw it, though. Um, one, two, three, four. I already lost count. I lost track of which triangles I've counted. Big triangle, one, two, three, four, five. I'm missing two. Oh yeah, yeah, yeah. The two mirrored ones. There we go. 10 triangles with 4 vertices. Those are the ones that I just drew. 5 triangles with 5 vertices. Oh yeah, okay. I see the 5 vertices. 10 triangles with 7 vertices. We should write this down. I'll just do an example of each. So 4 vertices is like A, D, E, and A. Oh, that's not A. A, B, C. 5 vertices is like B, C, D. Seven vertices. I guess are the giant triangles. BCE. And the magenta one. BDC. Or BCD, like that. And there's 2 more 3 vertices, which I guess I may as well write just for completion's sake. BDE, my favorite triangle. BEC contains E in a way that is distinct from... Wait, okay, capital BEC. Yes. From ABE. I agree with that. Edge versus interior. Oh, I don't know what you mean with edge versus interior, actually. I was just imagining that, like, not all 7 vertices triangles are necessarily, like, doing it in the same way. If you draw many versions of colored triangles on the side, it'll be easier to spot them later. Yeah, we can do that. Maybe I'll draw it in the same orientation as I drew them up there. Where did my cursor go? There it is. It's hard to see the dark blue on this background. It's a bad idea. Okay. Oh, and thanks for the follow, Echo. Yeah, it's tough with exams. Okay, let me catch up with chat. Another random idea. The different vertices lie on circles with different radii around the center. True. But group them by that, create some structure that helps classify the edges. Maybe, yeah. That's a random thought, but it's worth like thinking about. Was trying to understand, I like this better. Sometimes, like Pick's formula, edge points are counted as a half. I'm not clear it's any better here for this though. Oh, how does the circle thing apply to bigger polygons? Oh yeah, I guess that's a good way of talking about them. I can see the circles that would go through. Well, for like the octagon, it's a little hard to find the circles that would go through like... I guess you have different circles for each of these 3 points. Yeah, never mind. You can definitely make a circle. It's just... I'm not quite sure of the grouping. Like, are this point and this point on the same circle relative to the center? I guess they have to be. Yeah, okay. Same radius. Okay, that makes sense. I know, Winklebot. Oh my god, it's been 5 hours. I meant to wrap the stream like 2 hours ago, but this problem, I didn't realize how like how much we could talk about it. I know, I didn't think I would get this into the problem. The theorem? I mean, this is the current operating theorem that's a result of ChatGPT, apparently. We're trying to figure out a way to justify it. The farthest we've gotten is that n choose 3 corresponds to like the big triangles. Like it's maybe easier to draw on this one. Like it corresponds to like the triangle like that. We're using only the outer vertices. If you have 4.5 hours yet, you can go to your probability theory lecture. 4.5 hours? That's not enough sleep, especially for probability theory. Good luck, Echo. You should get some sleep. Actually, you know what's interesting? Oh, yeah. Like, I'm not even sure n choose 3 are those triangles anymore. Wait. So I'm thinking you have this triangle But you also have that triangle. No, I think it's fine. Never mind. And just are the big triangles. This is regular semester time for you? In July? Yeah, it's like late August through like mid-May, usually. Oh, that's true. The Southern Hemisphere does exist. But if Echo has to be up in 4.5 hours to go to class, I don't know. You don't need to say anything about your location if you don't want, Echo. No, I was thinking about that in terms of like the time zones. So they're probably somewhere where it's like pretty freaking late. 'Summer semester began on 1st October over here. Summer semester begins on April 1st. Wow, in Germany. That's wild. I didn't know. I never had another German mention the dates that they actually attend class. I don't think. Look at 5C4. Okay. Five, choose four. We have 4 sets of something. Five things and we're choosing 4. Hmm. Universal combinations with integrals? It's kind of wild. I was just curious if like these alternative representations had anything interesting. No, it's there's no way this is going to be helpful. I'm just thinking about different ways to express combinations. I don't think I still want to find an identity that's useful. I don't know if there's going to be one. Something power series. I would bet it's something gamma function. Analytic combinate true fizzbuzz. Don't even with the game. Oh, that's true. You still have PTSD. At some point, the gamma function will become your friend, Winklebot, and not just a trick that your professor plays on you, or whoever plays on you. What math devil am I summoning? An evil one, Leo. No worries, Echo. Yeah, absolutely. Feel free to share whatever you're working on. I might not understand it, but we can still like talk about it. If you find anything, please feel free to like let me know. So yeah, Leo, we've been on a bender. We started by looking at this question number 5. How many different triangles are there in this figure and just with the pentagon? Maybe Leo, if you sacrifice enough goats. We started just with this question, and we've been trying to generalize it for any polygon. So Dr. Cook generated these in Mathematica for hexagon, septagon, octagon. And ChatGPT apparently gave this formula for an n-gon. And so we're trying to figure out if we can justify that. It seems to be correct up to potential degenerate triangles. So it might be off by like 1 or 2 or something. Okay. Sleep well, Echo. But how many valid Tetris blocks you can create with n tiny blocks? Ooh, that is cool. My graph theory professor next time you see her if she ever thought about that. Nice. We're talking about combinatorics, probably Ian Stuckey. Yeah. 5C4 could have to choosing 4 vertices. Yeah. Get rid of the 7 vertex row. Right. That is. Yeah, yeah. Sorry, I had that like mentally worked out in my head. I didn't actually write that down though. But no, you're right. That's good to actually say. We're also a quarter of the way through this 24-hour stream, true Winklebot. And it's gonna be a 24-hour combinatorics count the triangle stream. Oh god, please. Yeah, I know. I was waiting for a follow-up. I respect leaving it vague though. Go to the larger. Are all triangles one of these classes? Contains 3 vertices, contains 4 vertices, contains 5 vertices. Yes, there's 7 fundamental triangles in this, and this is 7 fundamental triangles. Oh, you mean, oh, sorry, you mean larger. I see what you mean. I doubt it. We're winning so hard at Roblox color cone. You wouldn't believe how hard we're winning. Okay, can we find a triangle with like an interior triangle with like 6 or 7 vertices? That's not all 3 edge. Sure, you can make it even more crazy if you want, Winklebot. I don't know if we'll work on it right now. Wow, the way this is connected actually you might be right, Dr. Cook. Wait. What about this triangle here? That's a bunch of vertices. Can we solve for the number of regular n-gons? I don't think there will be that many regular n-gons. I think only triangles and whatever the original shape was. I can't imagine there'd be another n-gon that's regular contained in this. That's my guess. Well, you can find multiple, like I think there's multiple octagons inside of this octagon, but I don't think there's going to be a hexagon. I can't imagine there's going to be a hexagon. Yeah, the center would always be one. The music is epic. Thank you, thank you. Even then, Cook, if that was the explanation, I think, like, that doesn't explain the coefficients. I don't know. Something to me feels special about these two triangles just being reflections of each other. Like, they're congruent, whereas these are not congruent. And even weirder, like, this triangle is congruent to this triangle, but they're in different categories. I don't know. Find all regular polygons possible based on the original shapes and sides. I don't know, Winklebot. Hmm. The green? Yeah. Maybe it's like a multiple though. Oh wait, where is it? It's right here. 1, 2, 3, 4, 5. Wait, do we count? Oh yeah, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which is a multiple of 5? But then like maybe multiples aren't right because what about like composite multiples? How would you count those? Like 20. Was it a 5 or a 4? Can you make... I wonder if Wolfram Alpha could do this if you make it count 3 cycles. I bet Wolfram Alpha could do that. That's Mathematica, I mean. I don't know how. And I don't know if my Mathematica University access is even still active. Actually, this is not a 3 cycle. Never mind. Can I draw the original green triangle? Had 2 exterior vertices, not just 1? It did? Oh, was it this one? It did. Oh, yeah. Sorry, I misremembered what the green triangle was. You're right. I am Floppy, yep. Some graph theory demons. Which is probably just Ian Stookie. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. I wonder if it's the number of edge vertices that they involve is the important thing. No, I don't. You think it may be correct? Oh wait, actually, yeah. The reason, yeah, okay. The reason I think it didn't work is wrong. So these big ones all include all three edge vertices. So do 5. That one is also 3 edge vertices. Wait. No, is that big C or small c? It's big C. Oh, never mind. No. This is 3 edge, that's 2 edge. Wednesday is the day to make your move? Ooh, you did make a big move. What, with work? The edges of the screen triangle can be defined from only 4 of the 8 exterior vertices. I think your big green is indeed in the NC4 class. We can't define this from all... Can we define from 4 of the 8? Really? Left, bottom, lower right, upper right. Wait, so I couldn't do it with upper left here? What is that triangle? Those 4 of the 8 are sufficient to draw that big green triangle. It's probably the prefactor. Huh. Took 2 days of pure anxiety before doing the move. Oh, okay. Four times 5, choose 4. Maybe, but like we already like this class is not or like n choose 3 is not, unless we'd have to reshuffle like this, but maybe that's not a problem. Hey, Papadoria. Yeah, we've gone off the rails with this problem, Papadoria. It started just with an innocent puzzle. How many triangles are there in the figure? And we did that. But then we started trying to generalize it, because this is just a pentagon. And we're trying to generalize it for any n-gon, and it's getting kind of crazy. So, ChatGPT said this. We were trying to confirm it or justify it in some way. If you recognize that, that's kind of amazing. Okay, and I do want to wrap up the stream soon once we get through this explanation, I think, Dr. Cook. Okay. Here's our n equals 4 square. Two classes of triangles. Big triangles like that, small triangles like that. We made small progress, I would say. The big triangles do need 4 vertices to be defined. Is it like a little bit backwards? The small triangles only need 3. Or oh, but you're saying you need D to define O for the small triangles. Is that what you're saying? Okay, then I'm with you. You're on a train? Oh. That's Papadoria. This is the n choose 3 and n choose 4. So why is it 4 n choose 4? Oh, well, okay. Because we have 4 of them. Yeah, because this would be 4 choose 4, which is just 1. So in this case, the prefactor just counts duplicates of that one unique triangle. Yeah, it gets harder for higher order shapes, or for higher shapes though, or bigger. I don't know. I'm trying to wrap up the stream, to be honest, Benbox. So you want to be able to unravel for that long? This has been way too long. No, it's okay, Cook. I'm really interested to figure out this question. What are we counting in this square down here, Flofi? We were counting. This big ABC triangle is accounted for by this 4 choose 3 term, we think. And these small AOB type triangles we think are 4 choose 4, but then multiplied by 4. I don't know if you're here for the original part of the question, Flofi. I forget when you left. In general, the question is how many triangles are contained in these shapes. A very long time ago? Okay. Let me show you the original question. This was the original question. A pentagon with all the diagonals drawn in. How many triangles are there? We figured that out a long time ago. We're trying to generalize that for any n-gon, though. And so ChatGPT said this formula here exists. Papadoria said he might recognize it. I'm not clear on that, though. We're trying to justify it. Just draw a regular n-gon, then connect each point with a straight line segment, then count all the triangles. Yes. Do n equals 10 and tell us what you get. Right in this form. Oh, okay, Papadoria. I bet there is some graph theory source here. That's what I've been looking for. There's a way to unironically do this with generating functions. That would make sense. I would believe it. No, Pulp was just restating the question. So yeah, that's where we're at. I've also been going for like 5.5 hours, and I want to turn off the stream some point soon here. But I'm also really interested in this conversation. This is combinatorics from the boundary vertices. Yeah, right. So the theory that Dr. Cook and I were talking about is each of these terms can maybe be explained as how many external vertices those triangles need to be defined. That's Dr. Cook's thought. It doesn't explain the 4 or the 5 yet. Or the 1 there, I guess. And just represents making quadrilaterals inside the n-gon. Each one's quadrilateral gives you 4 interior triangles. Oh! Interesting. How many? Okay, yeah. Okay, god damn it. That's a really interesting thing, Dr. Cook. Why'd you have to say it? How many quadrilaterals can we find in this? Ugh, okay. No. There's a quadrilateral. That's only one triangle, though. That's not a quadrilateral, is it? I think I messed it up. No, it is. Forget the internal... Oh. Okay. Okay, yeah, there are n choose 4. Okay. Those can be further sliced into 4. I mean, there's way more than 4 triangles inside this quadrilateral. Is there a way to do it without overlapping? Of a certain class. Right. So one problem I solved was about constructing kites inside a circumscribed triangle. Some big zeta-like generating functions. Oh, cool, Papadoria. Yeah, I'm trying to figure out what class that would be. Right. And then we need to exclude like any like n choose 5. Okay. So we would want these. We would want those. We would want... Are we looking for 4 of these? Or like 4 distinct... No, not 4 distinct ones. Okay, yeah, okay, wait. No, don't wait. Yes, wait. There are 4 of these triangles, the blue and the green, if you count them as one class. Okay. That rely essentially on all 4 of those vertices. They recognize the song? Oh, okay. I thought Neil Kelly was like a mathematician or something. No worries, Femlux. Okay. So I think that's the class of triangle that is in n choose 4. N choose 5. So what's the n choose 5? All 5 vertices. I bet it's the small triangles. Why is it times 5? Because you can rotate the pentagon 5 ways, I guess, or something. It's a little bit hard because n equals 5. It might be more clear in higher and bigger polygons. You want triangles as vertices? Yeah, that's where I'm getting... Actually doing that construction in my head is where I'm getting stuck. If I try putting salt on it, I have not screwed. Okay, are we gaming yet? Oh god, I see we are. Um, I think you have the idea of it, Cook. This seems like the right idea. That's true, Skirt. You get to get the 5, choose 3, but not the other ones. Yeah, Res, links are turned on. Oh yeah? I'm pretty sure I follow him. You recommend him for a raid? We can do that. Yeah, I mean, that's Chris, right? Skirt, thank you so much for gifting Res. I appreciate you. Realize n is the number of boundary vertices and choose forms to interpret as choosing 4 boundary vertices or edges. It is him. Okay. Please pay you back. You can't do that to me, Skirt. How dare you? If I realize n is the number of boundary vertices and choose 4, it's interpreted. Choosing 4 boundary vertices or edges. Yeah, that must be it, Cook. Oh, okay. Yeah, Floppy, I thought about 3 cycles and I didn't know how to solve that issue about like you don't have true 3 cycles for most of these triangles. But yeah, if you can eliminate them somehow, that would do it. Wait, I hope you guys aren't waiting for me. You guys should be playing. Please, like, if you guys are just waiting for me, please start the game. I'm planning to raid out soon, but like, I hope you're not waiting for me. You said the chat room, okay? Programmer way to think about it. Yeah, I bet that would be easier to code up, Floppy. What did you send me, Dr. Cook? Oh, that one looks cool. I'll show that just because it is fun. It's no longer satanic. All right, count the number of triangles inside this, guys. Go. Actually, what does OEAS say? It's probably going to be like 1,000 something. The question is literally like one of those Facebook like posts that like everyone is saying. Just how many triangles are there in this figure? That's literally what we've been talking about for like 3 hours now. But we're making it way more complicated than it has to be. Yes. I won Papadoria as payback. Hey, Teja. Okay. So Club Penguin handle. Hell yeah, Floppy. Okay. It still needs to be fleshed out a bit, but Cook, I think you got the important idea. That's true, Skirt. Polish artist online who also goes by Floppy, not the only one around. Oh, cool. Thank you, Quinner. Aw, you're my star, Quinner. Yeah, the factors are still weird, but... Okay, we're wrapping things up right now. Thank you for saying hi, Rez. We will... Oh, I mean, I think it's the same logic, though. We still have the issue with the prefactor. YouTube, goodbye, YouTube.